All right. Good morning once again, everyone. Welcome to week 2 of our training, despite what that says. Um, we are going to be working through several things this week. If you would hit the next slide, Ted. So, like we said already, if you haven't just said hi in the chat, if you could do that, it's a quick and easy way for us to take attendance, more or less, just to make sure we know who all is here. Today, our major topic of discussion is going to be overrides. We've got obviously have some homework related to that we're going to discuss. We're going to talk about sequence of operation a bit. And then we're going to, because really overrides often pertain to sequence of operation and give us some of the importance why overrides can be both useful and dangerous. But then we're going to discuss overrides a little bit more in depth. This is going to be a group discussion, which means you will be participating, whether you like it or not. No, I didn't mean that, did I? Anyway, you'll like it. We know it. We will talk about how we find overrides, at least the easy ways that we've discovered. And then we're going to get into preventing and resolving overrides, which is really one of the more important things we need to know about overrides, right? And then we're going to talk about the impact of overrides to energy usage, which is a really interesting discussion to have.
Yeah, I just want to throw one thing here too, just so on our end if you put your name in there, please do put your full name in, so it just works better when we're trying to track everybody. Thank you.
Awesome. Thank you, Ted. And I know last week we said we were going to have lab at the end of this week, and I'm still hoping that we can, but we ran into a technical challenge. One of the more reliable services that we use kind of had an issue. So we're waiting on tech support to help us to resolve that. If we get it resolved in time, we will still have lab this week. Otherwise, we will shift that to next week and just have a little bit less talking head time in exchange for it, if that sounds reasonable to everyone at least. Sounds good. So Ted and I are going to be your primary presenters today. We've got Larry and person we forgot to introduce last time, Kim, who is our Zoom expert and makes sure everything is running and working for us, running in the background. Next slide. Here again, just for anybody who hasn't done so already, please enter your name into the chat to say hi, full name. That way we've got you on the sign in. I know we just had someone join. That's why we're repeating it. All right. And a reminder from last week, we are learning as a team here. Ted and I do not know everything, despite how we may present ourselves. And you know a lot. We want you to participate. That way we can all learn from each other. That's the best way for this to work. So ask a lot of questions. For those of you here last week, you noticed I have a vocal tick where I keep asking, do you understand? Do you have questions? Again, that's just me checking back to make sure that I'm not going too fast or missing something. We'll do our best to keep live in the chat as we go, as far as answering questions and things like that. But if you have any, go ahead and raise your hand if you want to unmute and ask, or throw it in the chat, whatever you'd like. I don't promise we'll answer every question at this time, but we will do our best to answer as many of them as possible that apply now, and we may kick the can down the road to answer some of the others. Again, sound fair to everyone? All right, let's get into the meat of it. Let's talk about overrides. Next slide, Tim. Thanks for the feedback, Antonio. Love it.
I noticed that too. That's why I smile.
All right. What are overrides? Well, simply put, they're getting in the way of the system doing something automatically. They could be well, we'll talk about all the things that they could be overriding. But from the most simple perspective, that's what they are. A lot of times we use them as a band-aid fix to get past an issue when we don't have time to address it properly, or the access to address it properly, or the parts to address it properly. Please note I'm separating overrides from actual fixes because they really aren't. We are going to talk again about how much energy can be saved with finding your overrides and getting rid of them. And that's really a complex topic. But why are we talking about them right now? You know, you would think that if we were talking about things that can save you energy, can save you money, that really we'd start with really big, simple, impactful things. Like, for example, schedules. Schedules, the amount of energy they can save is really pretty obvious. The gains are pretty obvious. They're easy to do. But so many of the things that we work on with energy efficiency rely on a functional system, right? That doesn't just mean the hardware side, that means the software side as well. And if we are using overrides, again, we're getting in the way of the system doing something automatically that it wants to do. Now, it may not be doing it the correct way. It may be doing it in a way that we don't understand why it's doing it. But it wants to do that, and most of the time, it's going to be the most efficient way for it to operate. So that's why we're talking about overrides now, so that we start off with an effective functional system, and then we can tune it to be more efficient. Because if it doesn't work in the first place, you got problems, right? All right, next slide, Ted.
Well, and this gets us into discussion about what your homework was from last week and what you found on your systems. So we're going to basically kind of turn it over to you. Find out what overrides you found on your system, where they were, you know, what type of equipment it was on, why was it overridden? Is it something you were able to resolve at that point, or something you're planning on resolving? You know, do you have a plan set up for that? And, you know, as you talk through them, we can talk a little bit about what type of impacts that particular override had. So with that, we're going to turn it over to you guys to find out what you found. So
I'll go first.
All right, Adam, go right ahead.
So we had an event last weekend, and typically the lights will not come on unless we do have an event or whatever. They did not. So I had to override. Both my overrides are on the same system, but the light locations are in different places, so I had to test them all. But basically, I had to override the scheduling and the PV sensor. I just set a higher priority for on than those had on them, and they relinquished it. But it turns out we just had no network. I knew it from the get-go that the network went down, but I had to determine that that was the source of the issue. So I saw that the commands, you know, were sent, not received, and that it was scheduled properly in our event system, that the times were right, and they selected the right parameters. But it turns out we lost the network for the entire county for the entire Saturday. But I did my due diligence because it was reported. And I had to verify that it was working properly because we've also worked on all that lighting recently.
So how'd you get them lighting so they can have their event?
No, it was working fine the entire time. It's just that the network was down when the schedules were due to be sent. So the lights never received the schedule because the medium in which they were to receive the schedule didn't happen. So they just went on at the standard PV time rather than when they were scheduled to be overridden. Because typically they like the lights to come on a little bit before it gets dark if they have people on site.
Yeah.
And also I had another override, but it's not as big. I wanted to make sure that a system could AC at the lower end of the local set point on the stat. So I overrided the stat so they couldn't use it and set it up the 4 degrees that the range that I give them, just to make sure it could hit the lower end of that cooling temp. And it didn't. So there obviously is an issue with the unit.
Okay.
So, fantastic. You found 2 separate overrides, or actually caused them in both of these cases. One you used very, very well as a temporary fix while, an issue was being resolved. Once the issue was resolved, you already said that you removed that override on the lighting system.
Right. Relinquish is the term that Reliable Controls uses. And I believe most of the systems do, that you're relinquishing priority. Forgive me if I'm using the wrong terms. This is all fresh to me.
That's one of those things. We've got all kinds of terminology, but yes, relinquishing is absolutely an accurate word.
Yep. Next.
So who wants to speak up next? All right, Jessica, go ahead.
So the first one I have is a little bit embarrassing. When I first sat down at the building automations desk, I was like, man, there is so much stuff in override. Like, how can anyone determine what's happening here? So I cleared every override in the system. And one of those was a lead lag on 2 circulating pumps. And the reason was that one of those circulating pumps needed to be repaired. So when the lead went back and turned that pump back on, it burned up. So that was not great. But after we got that pump rebuilt, we put it back on lead lag and it's working fine. So don't clear those don't be too hasty to clear stuff. And then the other one is we have a lot of air balancing issues. Our high school has kind of been built in stages. So the gymnasium is sort of in the center of many zones. And the doors will blow open because of the pressure inside the gymnasium compared to the pressure in the zones outside. So there's 4 relief air dampers at the roof, and they're all in override at 15% open. And after, lots of research into this, there's many different variables that can control when those are supposed to open, but basically they need to be an override because they'll close and it gets really hot in the gym, or the doors will start blowing open, or they'll open and it gets really cold. So they kind of are a little touchy, and we just have to kind of keep them pretty much between 5 and 15%, depending on if there's an event going on, which isn't ideal, but it's the best we can do right now. So those are mine.
I wonder if gravity relief would help out with that, but yeah. You have any thoughts on that one, Robert?
No, building pressure problems are definitely a often very complex to resolve, especially when you have, and as you stated, a building that's built in multiple sections. So as things go on, sometimes you have to go back to what was already done and reevaluate how it's supposed to be working. And you say there's a bunch of sequence and things like that in place for that, those dampers, but obviously they're not satisfying the current need. That is going to be a topic that we're going to touch on here in a minute, because understanding that is critical to sometimes understanding why overrides happen and how to resolve them. So in this situation, it may be obviously is a very complex issue that may need a little bit more outside help to resolve. And of course, we all know that becomes a priority shuffle to see what can and can't be done right now. You have it in under control in manuals, so chances are it's probably going to shuffle to the bottom of the deck for a while, but eventually, or the next time you've got a service contract out or something and they're looking for something to do, that could be something to look into. But yeah, complex issues. Adam, did you have a comment to add, or were you volunteering to be up next?
I was volunteering.
Okay.
So we just to refresh everyone's memory, we have the Schneider Electric iNet Tech from 97 to 2004 is the software. So a lot of it's running on Windows, or all of it's running on Windows 7, but we have some major overrides, unfortunately. We are slowly starting to upgrade things. We're starting at the high school. We're having Dynatech is going to be our new system, but we have some major overrides on the chiller right now because we're also having work done to the chiller boiler plant. These are all things that haven't been touched since 97, including the building automation. So right now we're running the cooling tower in hand. We're running 2 pumps to achieve GPM because the new pumps are in and they're designed for the new systems. So we just have a lot of VFDs in that room in hand right now. Some of them have multiple pumps running, like I said, to achieve the GPM we need. So we have a double barrel train right now, and it needs 1500 GPM to achieve what we need to cool the building down. So yeah, we just have some major overrides right now. So, but we're just keeping our fingers crossed. We see the light at the end of the tunnel. So we know that we're getting to a point where, hopefully in a few years, the whole district is done. So we're a smaller district. We're only 7 buildings. So shouldn't take long, but I've been here 4 years and it's something I've been waiting for the 4 years.
So there's a good example of using overrides to help ride through some system changes.
Yes, absolutely. And unfortunately, we have a lot of old Barbara Coleman beer can actuators throughout the high school. So a lot of them have overrides on those. I'm still not too sure how the old controls company actually was controlling them. We don't have the proper voltage to achieve the stroke on the valves. So it's all kind of like, there was a guy that was here for the high school for 30 years, never left the building. And I think now I know why. So, but yeah, I have a lot of beer cans that are actually pulled and I'm manually pulling the stem up or down just to achieve flow in a classroom. It's unbelievable where we're at right now. So.
That sounds difficult. It's exactly what you don't want to have to be doing when you have a control system in place.
Yes. Unfortunately, the forward thinking wasn't there in past administrations. So we're finally, we have the right guys in place that are making sure we get all this stuff done. It's just, it's a lot of the buildings, not just the high school. So.
Yeah. Well, at least you're not running into situations that both Robert and I have found where you come across a building, you're looking at it and they have a really nice DVC system, good graphics. They can easily control from their computer in the office, but yet somebody has gone and changed everything to manual, disconnected things. And I'll show some examples of that coming up. But they basically, in that case, they're overriding the system due to lack of understanding. That's something we don't have to get into.
Yeah, overrides on a system that has been in place, and honestly, its day is come and gone. Overrides in situations like that are a fact of life. It sounds like yours is maybe a little worse off than some, but at least you've got some idea of moving forward how you're going to resolve it. And a new updated system, replacing a system that's coming up on 30 years old is totally reasonable. Honestly, that's been a good service life. You know, most systems run about 20 years before they get run over by IT and need to upgrade. You know, to your point, so many systems still running on Windows 7 when that has been unsupported for a minute. So you know, that kind of thing happens. I will offer one piece of advice coming from the operations standpoint as you go through, especially like on your example of your chiller, when it gets replaced and the new chiller or chillers come into play, make sure that those overrides on the VFDs get resolved while the contractor is still there and present. And as the contractor goes through and finishes areas, double check that everything works the way it's supposed to. You've got, because this is an active project, you should have good access to the documentation to see and understand how it's supposed to work. Make sure that it does. Test it all before the end of the warranty period. Hold your contractor's feet to the fire. Make sure that they make it work the way it's supposed to work. Because fighting those battles after the fact can be really, really challenging. So getting them done beforehand, really helpful.
Okay. So who wants to step up next?
Hello.
Hey, Gene.
Hey, how's it going?
Oh, beautiful.
Great, great. So I have a situation, and yeah, I know I know about this override, and it's with a particular school. The school was built in 1999, and the original controller, Metasys controller, NAE, um, fashioned. That's the model type. It's giving us trouble. It's not stable, and what happens is that it seems like it's rebooting or flickering and causing the uh, only the occupied cooling and heating set points across the building to reset to a default setting, and this default setting is 70 for heating and 74 for cooling. And as you know, and this is happening frequently. Sometimes I might be able to go 24 hours, 24 and 12 hours, but eventually it's going to happen, and I get these comfort issues. So um, either I or one of our technicians, they will override the occupied cooling and heating set points so that we could avert most of the changes. Now, that's why we're using the override for the cooling and heating set points to set them at somewhere about 73 for cooling and 68 for heating. We're in North Carolina, so we've been experiencing 80 plus degree days for the last 3 days. Today is an 80-degree day. So it's water source heat pump for about 220,000 square foot building. And so that's what we're using the overrides for. Um, it it works, but it doesn't work. We still have to change quite a few of them, and really there's no need for us to even try to override half of them. The other half does stick with the overrides, and when I say stick, we keep the set point setting. But that's what's going on, and that's the reason why we're using that until here's the fix, until we're able to afford the $25,000 price tag to change out the building controller. So, yeah, that's what's going on there.
Yeah, NAE,
Yeah,
that's their last version, not the most current version for Johnson Controls.
no, yeah, you're
Network
right.
application engine. I know we
Yes.
had some in our labs and they're having issues. So we were lucky enough to have JCI go ahead and replace them for us as one of our partners. Luckily didn't have to pay for it. So
Do you think I can ride off of that? You know, since I'm associated with, this effort now, that we could take that same agreement over here at
I
Rockingham County Schools.
I doubt it. They did that because they want us to be able to train technicians, ideally use their equipment so that they can bring them in and use them. So they're one of our partners that has been very active in helping promote things that way. So I wish I could say yes, but probably not.
Yeah. The other one, and so I'm going to use the dog ate my homework assignment, um, excuse. But the other one, I was able to find an override at a particular school's auditorium. The building is rather large. It's probably our largest freestanding building that's not a classroom or a school. The auditorium has 2 stories kind of, and it's a huge, massive brick construction. I would say, I don't know, I'm guessing about 10 to 20,000 square feet. I could be off. But anyway, we have a cooling tower, water cooled chiller, a boiler that services that building. And I noticed in the folder for the central plant that the condenser water set point was overridden to 77 degrees. And I wasn't for sure. So this is the part the homework that I didn't do. I didn't research why it was overridden to 77 degrees. When I released the override, I'm also very careful about releasing overrides as I was instructed. Uh, as I was instructed very carefully and repetitively when I was learning building automations for Metasys. Um, but I released the override and then noticed that it just went to 80 degrees. So it was a 3 degree, 2 degree, 3 degree change. And I kind of watched the system to make sure that we were still getting the same results. It happened to be during an occupied time that we were in occupancy for the system. It didn't seem to cause any issues. I've watched it over the past week. We're still performing well, and so I left the override um, out, and it's running at that condenser water set point of 80 degrees, which is strange for condenser water set point. You guys would have to explain that to me.
I've got some theories on that one, if you don't mind, Ted.
Go right ahead. I'm
So
blank at the moment.
a couple of quick questions for you, Gene. Remind me where in the country you are.
North Carolina, right on the border of North Carolina and Virginia, central part of the states.
Gotcha. Do you know what kind of chiller is in that building?
What brand?
What brand, what type, centrifugal, screw, etc.?
Yeah, the only thing that the brand I can't remember, but it is it deals with water. It pushes cold, produces cold water
Right.
and it uses the cooling tower, I guess, to kind of help that process
Gotcha.
in the process of conditioning the space.
Gotcha. So my guess for both there's some sequence of operations stuff that we'll talk about here in a bit that can definitely affect are set points as far as condensing water goes. Because depending on your outside air conditions, especially obviously outside air temperature and humidity, we can only get our
Yes.
condensing water so cold. However, there are a lot of chillers out on the market, have been for a long time, that prefer their condensing water within a specific range. And especially on centrifugal chillers, when it's outside of that range, we can end up with a really problematic issue called surging in the chiller, which is basically where we have a pressure differential problem across the compressor, and it literally sounds like the refrigerant is surging within it, and can be very, very damaging to the chiller. So that could be why you are seeing what you're seeing.
Okay.
A 3-degree temperature change on the condensing water could have been part of a solution to that surging. And that's something that unfortunately we typically don't have a good way to monitor remotely. So it'd be something to keep an eye on the chiller physically if possible, or in this
Okay.
case, an ear on it, to see if anything weird starts to happen.
Okay.
The other thing, somebody could have been trying to be clever, and by dropping that condensing temperature, they might have been able to eke just a little bit more BTUs,
Cooling?
basically, a little bit more effectiveness out of the chiller on a very heavily filled building, or a little bit more efficiency when it was only partially filled, but needed chilled water, but it was still kind of nice out, something like that. But yeah, do look into the history of why that override happened. I guarantee there's a story there that'll be, one, interesting, and two, you'll be able to really learn something about that building as a result.
Okay. Great. Thank you.
Great examples.
All right. Who wants to give their example next?
I'm
Yeah,
willing
I'll
to
go
go.
ahead.
All right, Tyler, go ahead.
I'm Tyler here in Des Moines, Iowa, and so recently we found an override from a couple months ago where a rooftop air handler had an outdoor air sensor that the unit was in cooling, and then on a sunny day, the sun hit this outdoor air sensor and made the unit trip into 100% cooling. Well, it tripped the unit out, and we lost that unit. So at that time, somebody decided that they'll just override that sensor to 66 degrees, and recently found out that, hey, we're going to go back and do some programming, but that never got done. And so found that, completed the programming to use a different outdoor air sensor, still at the same facility, but underneath an overhang that won't be impacted by the sun hitting that rooftop and causing that issue. And then another one was at one of our biggest high schools. We recently had a construction project about 8 months ago, and they decided to leave the equipment in place, just abandoned, but they, rather than taking the equipment out, just overrode all the points off, or made it look like the unit wasn't working. Well, so kind of went through the process with construction, making sure that these units are actually, they're not connected to anything, there's no use for this stuff anymore, and got those points removed from the system so that the next cold day that somebody really wants heat in a space, our technicians aren't going to go out and be like, oh, this stuff's overridden off. Why is that? Just power it back on and there's really nothing to do. So kind of just cleaning up the system a little bit and making our way through the override list.
But First thing that comes to mind with your outside air example is, and you probably already did this, is just make sure that sensor's in a location that's not in direct sunlight and, isn't misrepresenting outside air conditions.
Yeah, this sensor was in the rooftop unit, so probably not. We were probably
Right.
getting inaccurate readings for the last couple of years anyway, but it came to light when we just had a drastic temperature change to where we went from 100% heating to 100% cooling within an hour, and that unit just tripped off, and kind of that's what made it come to light.
Yeah, those extremes can often trigger an event that helps you find weak spots in your system.
Yeah, no kidding.
Yeah, and when those sensors are built into a unit, it does make things particularly challenging sometimes with getting them to accept a better reference for the temperature. So glad you were able to resolve it though. That's always a good win.
Mm-hmm.
Okay, who would like to give their example next? I see that Antonio talked about, it's amazing how forgotten overrides can exist in the BAS system when you run your reports. So just kind of underscoring the need to run reports once in a while on it. So anybody else want to step up next?
Yeah, Damian Hill, King Salmon, Alaska.
Hey, Damian.
I don't have access to our system right now. Not the keys to the kingdom. I've been fiddling with it quite a bit. But two examples that we have is we run diesel fired boilers in the villages, and when the occupancy mode changes to the evening and they go down to a cooler temperature, when it's 40 below wind chill, it freezes up the system. So we lock out the or override the boilers and just let them run in like occupancy mode turned on in the evenings. It's a big demand, big expense for us, but it's the only way to keep the building from freezing up when it reverts to that cooler temperature, unoccupied mode. And then the other example is we have a makeup air vent in one of our schools, and same thing. When it gets really cold and it starts blowing from the north, we lock that out, we close it up, or else everybody would just be freezing in the building. It just like a tunnel of cold air blowing into the schools. So those are the two examples that I have.
Yeah, first one comes to mind for that cold weather override for overnight. There are ways to accomplish that. Maybe just let it go into an occupied mode, but maybe modify the temperature that it's going to maintain the space at during unoccupied mode would probably be a better override, just so you avoid, and maybe you've done this in a different way, but avoid having to bring in outside air. Is that a consideration at all for you?
Yeah, I'd like to. I'm gaining traction in the maintenance BAS system. I guess there's a lot of tribal knowledge, with the operator, and he enjoys monitoring the buildings 24 hours a day, 7 days a week when it gets cold, just because he's comfortable with that. Yeah, I believe that there's other ways, but I'm not there yet.
Yeah.
To build confidence with some of the people around me.
So maybe not just tribal knowledge, but politics. So.
Absolutely, yeah. And and one of the questions I initially had was in this building in particular, where we just Katie bar the door, we get it as hot as possible. When it's really cold outside, is, well, it's glycol, right? And it's like, no, it's not glycol, because we're constantly feeding the system. It's an old copper system, And so we're have makeup water all the time. And the reason I'm told we're not using glycol is because we're always adding more water on a weekly basis. And also, if you add glycol to an old system, it rusts it out faster. That's what I've been told. I'm not too sure about that, but it's just there's a lot of layers to every decision that's made.
What thoughts you have on that, Robert?
Definitely a complex issue, without a doubt. And anytime you get into that combination of kind of extreme temperatures and older buildings, it is definitely a challenge. But it already sounds like you've got one major item on your hit list as far as problems to resolve, is finding out why you're having to add so much water to that system. An old system, yes, absolutely, they do wear out, but especially if it's a copper-based system, that should have a hugely long lifespan, especially if your water treatment was ever done halfway correctly. Copper's really, really resilient for that. I would suspect a little bit of misinformation. I have never run into a system that rusts because of the presence of glycol. That is a really interesting one. Improper water treatment, absolutely. Building up of some additional mineral deposits and things like that because of, again, the water treatment. Yeah, that'll definitely happen. But rusting it out, that's a kind of a unique one. Now,
Yeah, our water treatment is we don't have that. It's well water.
gotcha. Do you have at least a water softener on that system?
We do not.
Okay, that would be another thing to look into, from a little bit more long term after you fix the leaks, because as you know, especially if you're running well water, you've got a lot of minerals in it, and a softener is a really, at least potentially, affordable way to pre-treat that additional water you're putting in so that you don't end up with as many mineral deposits, which can definitely cause flow problems in different parts of your system. The one item I would caution, and one of the default questions when we run into issues like this, matter of fact, we even saw it in the chat, was if you have glycol in the system, and you brought it up as a point. You do have to be careful. You cannot just add glycol to every system. And you have to have a good idea of what percentage of glycol needs to be in the system. Because at initial design, if a system is designed just to run off of straight water, it has a certain thermal conductivity or heat transfer effectiveness. And the more glycol you add, the less effective that heat transfer is. So you've got to really kind of balance that and hit it on the fairly correct numbers. But like I said, you already have your biggest item on that list is find the leaks and see what needs to be done to prevent it. Whether it's repairing leaks in coils, especially at your bigger equipment, or finding leaky valves or pumps that need to be rebuilt, have the seals replaced. Or it may be a combination of all of the above. You may just have an absolute sprinkler system of small leaks that need to be addressed a few at a time. But
yeah, it's a combination of things, guaranteed. We've replaced quite a bit of the system with PEX. Our next step is to, in one portion, we actually, some of the copper is underground, coming from the boiler shed to the school. And we've actually trenched it out and added insulated PEX to some of the portions already.
Very cool. And that is one of the other comments that I at least have heard on systems like that, older systems, that and the engineer in the building doesn't want to turn the hot water system off ever, especially in the summer, because the system will cool down and you'll start having leaks as a result of it, because of the thermal expansion of all of the joints. When they're nice and hot, they don't leak. When they start getting cold, they do leak. When I was first told that idea, I was very skeptical of the truth of it, but I've witnessed it personally, and it absolutely does happen, especially with older systems.
It does, yeah.
So,
And here's an interesting one. So we run heat exchangers, recovery heat from the village power plants also in some of our places. And in the summertime, if we turn the pump off for the recovery heat, we overheat the village system. So in the summer times, our schools are, when nobody's there, it's sometimes 80+ degrees in there, because we're acting as a radiator for the village power plants.
wow.
Yeah.
That sounds like a discussion you need to have with the village power plant for summertime. Not that
Yeah.
it's terrible if nobody's there, you can sink the heat effectively for them. That's great, but
Yeah.
that's also a bill that you have to pay. So
Oh, it's very complicated.
I can well imagine.
We haven't had to pay that because it was assumed free heat. And now that the village power plants are becoming more efficient, we're getting less recovery heat. So we're running our boilers more, which is actually costing us more because they're getting more efficient. Yeah, anyways.
Interesting.
Yeah.
Complex issues for sure.
It's very complex. Yeah, thanks.
One more thing on that, you talking about the glycol. The other concern there with glycol, Robert, is the more glycol in the system, the harder the pumps have to work. So glycol is just not as easy to pump as water. And so there's an energy penalty you pay there, and there may be other system ramifications resulting from that, but the main one is energy.
Good point, Ted.
Thank you.
Okay. Who wants to talk through what they have next?
Yeah, I was able to find a couple that I can talk about. So here in Florida, it's starting to heat up quite a bit, and we lease space in our schools every day. Every night, every weekend, there's always somebody, some third party in our schools. And as the weather gets hot, the humidity goes up, the schools get really concerned about large groups coming together. And so depending on what group it is, if it's government group that's going to use the school, or some group that gets them a little nervous, they sometimes complain about temperature even before the event happens. So as I was searching through, I found a cafeteria that had an override for the discharge air temperature was lowered 2 degrees. And so luckily it was a timed override. I didn't have to do anything about it. It was going to expire. I think it was set up for two events. It was a back-to-back thing. And so that one was, I really didn't have to do anything there, but I did find it. And that was in our train system. It's our new, the new train software that when there's an override, you can either run a report to find all overrides, or you can kind of scan through the system and you'll see like a little, I don't even know what it is. It's like a little indicator that something's been done with this point. And so I was able to find it like that. The second one I discovered was really not a surprise. It's we have a middle school that's had issues with the chillers since school started back in September. And so finally one of the chillers failed and they had to bring in a temporary chiller. So there were 5 overrides, a couple to shut down the chiller that was bad, that's either going to be replaced or rebuilt. And then there were a couple of overrides for the chiller that's working, to keep it online because you know, it's, I guess they get nervous when there's only one chiller, so they want to run it extended time. And then so there was also an override for the primary chill water pump. Also, you did talk about how the chillers surge, and that's something we've been dealing with quite a bit. And we found that it's some of our water cooled chillers, they have to have a certain amount of load. And if they don't, I guess the oil tends to migrate where it shouldn't, and the chillers start to surge. And it basically takes the chiller offline with an alarm.
Yeah, so on the chiller side, you might look into seeing if there is a way to limit the capacity of those chillers, instead of letting them run up to 100%. There may be a setting to limit them down to like 60% or 80%. I know older Carrier centrifugals had settings along those lines, and those are the ones that I have the most experience with surging. So you might look for something like that. On the overrides because of the chiller that failed, yeah, that sort of thing happens. It's an emergency replacement item, but you can't replace a chiller in an emergency. That just, as much as we would like to be able to, renting a chiller on a truck bed to come in and take up that load portion, it is really the best we can do as far as an emergency goes, because it's not just an off-the-shelf item as much as we wish that it was. So doing those type of things is it's a necessity. And if you're going to be dealing with that for a longer period of time, one of the potential things you could do is add a note on your graphics. Just kind of do a grayed out patch with like a watermark on it, chiller offline because of, non-functional, something like that. That way it's really glaring in the face of any new people that come in, so that they're aware of it.
Yeah, that's, as I was looking through trying to find these overrides, one of the things, I mean, because I've been here long and I kind of know the heartbeat of the district, I kind of know a little bit about most of our schools, things that are going on. But if I didn't, I don't ever see any notes. Well, I did see one note about the discharge air temperature, about that change. But if I didn't know that there was a temporary chiller out here at this middle school, I wouldn't know what these overrides were for unless I started, making phone calls. So I'm sure, you know, there is a way that you can put in a note in this system. This is a Schneider electric system. It's their new software, Structureware. So I'm pretty sure it has that capability.
Yeah, it does.
Yep. I don't see any notes.
And it might be one of those, you ask your controls contractor just for a quick 15-minute fix on it.
Mm-hmm.
Might be the easy way.
Yep.
What was the first override you mentioned? I remember you mentioning something. I had a comment, but I don't remember what the override was now. I got too interested in the chiller.
Yeah, the first one was a group that was renting space in the school, and
Right.
the principal was just concerned that, you know, the group is so large, it's hot out, they're going to complain and want money back. So he
Yeah.
asked to have the temperature lowered.
Yeah.
And so what they did was they lowered the discharge air temperature a couple
Right.
of degrees.
And that sort of pre-cooling type strategy can be really effective, both for when you know that you have a hot afternoon coming, when you have cheap power. There are lots of reasons we can use pre-cooling, and doing that timed override is a really effective tool for overrides, so that it automatically releases itself or relinquishes itself and moves on after that time period has elapsed. So that's a really effective way to do it, and a great choice. I would also encourage that since this is a regular thing, that maybe looking into a little bit of work to set up just a quick button so that you can set it to pre-cool for X period of time, and make it a really easy, normal thing. Because I especially if you're leasing the space, and I understand.
Yeah, I'm glad that you mentioned that because I think last week I mentioned that we use a third party for scheduling in some of our schools. And so when the school makes a reservation, Facilitron is set up to automate the scheduling. And what we had them do is build in pre-cooling for that. And I think the systems come on about an hour early. But even with that, the schools still get nervous, or the renter will complain about, that it was hot. And as you know, a lot of the churches, a lot of the groups, they leave the doors open as people enter the building. So, you know, of course, the space is going to be a little bit warmer than it should be. And then sometimes they may overload the space with bodies. And of course, that's going to make it uncomfortable. But we do pre-cool for all of our events that we schedule.
Fantastic. Maybe a little bit of additional training or contract work associated with the folks who are utilizing your spaces, along the lines of, maximum numbers of people, keeping the doors closed, those sort of things. It doesn't often work, but sometimes it does. And at least it gives the people who are receiving the complaints and, having to deal with the give us money back because it was hot, have line items that they can point at in a contract saying, you didn't follow these items, I'm sorry.
Yep.
All right. Well, I think, we have quite a few people yet to go through. So maybe if people start placing the type of overrides they found into the chat, that would be helpful, and we can kind of skim through. Robert, you have any thoughts on that?
Now let's do it. Absolutely. We do still have plenty of ways to go today.
Yeah, and we can kind of touch on them as time allows. But right now we can go back and take another person and talk about what they found. You want to mute themselves and jump on in. Go right
Hey.
ahead.
Good morning. This is Jeremy Polson from Anchorage, Alaska.
Hey, Jeremy.
Hey, so in my position, I have the closest access to the BAS. My coworkers, Larry, Morris, Nina, Molina, and Kaylee, Miranda, don't really have the access that I have. I have a group that works 5 days a week, and we have an on-call that actually, we have a BAS department, our automations department. And what I did was, my personal use for this RBAS is just for monitoring. If I get a complaint, I'm able to jump on and take a look and see what the problems are, and then effectively send out a crew that needs to do the work. So what I did was I approached my lead of that department, and he was running a panel point log report. And if I was to do the whole entire system, it was going to turn out to be it would have been a big headache. There's a lot of overrides that are across the school district here in Anchorage. 92 facilities. You can only imagine the things that we're trying to bypass and just make, comfortable learning environment for our students and staff. So what we were able to find in a simple search was for one of our larger facilities. It's South High School. And we found that one of the variable frequency drives was in override, and I'm not really sure the reason why it was in override, but after talking to one of the electricians, that I had found out that there was some issues with that VFD, and there's some parts on order. And once those parts come in, then that'll be repaired and the override would be removed or relinquished, right? So that was one of them. The other one was, we had a zone in that same school. The zone consists of about 8 classrooms, and there was a complaint. The rooms were getting a little hot. This is about the shoulder season of the heating and cooling time of year up here. So once it gets over 50 degrees during the day, we don't have any AC or any type of mechanical cooling. It's all free air cooling. So we'll be pulling, whatever heat that's produced off of a black tar, or, just a type of roof that creates heat on its own. We're just pulling that outside air from that roof. And that can be excess of 65 degrees at points like right now. So, so what they did was they commanded the mixed air set point. And right now, it's the warmest we get is about 52 at this moment. So what he had to do was he actually had to command that set point to 55 degrees. And that helped out quite a bit. I'm not sure what was causing the excess heat in that zone, but by commanding that to 55 degrees, it actually calmed the complaint, and they were able to balance that out. And I'm sure I'll get an update on it, since now it's on my radar. I'll follow up with it, but that's what I have for now.
Okay. Yeah, those warm roofs can really have a problem for using outside air for cooling, can't they?
Right.
And that's a problem with sharing an outside air sensor for a large building or campus, because you end up with pockets where that may make sense and pockets where it won't make sense.
Right.
All right. Anybody else? So make sure you put your notes into the chat on what you found, so that we can look at that during the course of the day and get some feedback to you. So with that, Robert, should we think about going on to the next section?
Absolutely.
Unless you had some other thoughts you wanted to convey here?
No. Well, I have plenty of additional thoughts, but I think we've all got most of them scheduled for future slides.
Okay, that sounds good. I'm going to just give one example of an override I've seen on a system, and it seems to be prevalent in building I'm in, where they override the VAV box airflows, and that just seems to create a lot of issues. Since I'm just an instructor, I can't go change or override or take that override off. But the problem I see with the way that they've done that is, if you override to a larger airflow than should be for a space, and you do that in multiple spaces on a given air handler, you end up with more airflow from that air handler. And in a cooling situation, if you don't have enough load in the spaces, you're not going to drop the discharge air temperature low enough because of the way you're just working with dry bulb temperatures rather than looking at humidity. And as a result, at least here in Wisconsin, we have humid summers, and you end up with spaces that can get really high humidity and cause moisture issues. We've had mold growing in the carpeting in some of the rooms because we're not drying out the air enough with these high airflows. So it's an override that I've tried to bring to attention of operations numerous times, and they're finally getting the message this past couple of years that they shouldn't be doing that, and the systems are actually starting to track with the VFDs controlling down less than 100%. Sometimes I've seen as low as 50, 60%. So releasing those overrides has helped to take and resolve that issue. I'll move on to the next slide, in which case we're going to start talking about sequence of operations and what the design intent is. So design intent. When a building is going to be built, somebody's got to create the parameters that that building has to operate and perform the functions that that building's meant to do. And that's where the design intent comes in. It's a document that they work with the building owner on and talk to them about it, figure out what type of operation is going to be in that building, and how they want to perform, temperatures, things like that. It's something that's very similar to what's called an OPR, owner project requirements, where you're defining in, and pardon this phrase, but layperson's term, that the building should be operating to meet the needs of the owner. And we want it to be in layperson's terms because we're going to have it as a document so the owner can understand what the building's supposed to be doing. I have a project that I worked on here, and there's 2 pages of design intent, and I'll just read you a little bit of it so you get a feeling. The design intent for the commission systems is a collaborative process between the owner and design team. The OPR defines the goals and requirements the owner had for the building. The OPR serves as a starting point for a design team to develop systems. And then the OPR leads into these bases of design documents that get into the more specifics of, okay, we're going to design in these type of outside air conditions. We want to have these type of temperature conditions in the space, and we want to meet it under these certain areas and occupancies and things like that. So it gets into a lot of detail when you go start drilling down from design intent to OPR and basis of design. The basis of design really gets into the mechanical type of systems. And that's where, for me, a lot of the information we use in our controls is drawn from to implement. So, Robert, I don't know if you had any. I see you're off there, but did you have any comments on it if you're still available?
No, I think you nailed it just right.
Okay. So where do you find these documents? The older the building, the less likely you're not going to find them. The building that I just mentioned is from 2007, and it was meant to be a commission building, so they really made sure they followed through with that process of having an intent, having owner's project requirements, and getting those bases of designs. The basis of designs, they should have been something that was considered long ago. In other buildings going back as far back as you can think of, they just may not have been documented. So you, excuse me, you can find them, but oftentimes they might be discarded in odd places, and so you might have to dig around for them. So that's kind of bad news, and most likely a lot of people don't have access to that. So with that, I'm going to move on to the next area and talk through a little bit about the sequence of operation. So sequences of operation is basically a set of descriptions of how the equipment's going to come on and meet space needs. And it sounds simple, but when you start getting into it, it gets to be a little bit complex. The base sequence of operations is more of a text type of description. When we put it into controls, it's a lot more detailed and it has to be very specific. Finding those sequence of operations, you can find them in your cabinets, your control cabinets. You might find them lying around in the maintenance area, might be on drawings, your blueprints. They can be in your control specs. Ideally, you're going to find something on your control drawings that were modified after the project was complete. So you have, what's the word for that, Robert?
As-built.
As-built drawings, and those are really helpful to have. You have any comments? It was like on the different levels there we just talked about, Robert?
No. Finding them is often the big challenge. Interpreting them or reading them and understanding what the intention is kind of a separate one.
And at each of these three different levels, building specs, blueprints, and control drawings, typically a different entity or person is developing this. So the project spec book is developed by the engineers before the project even goes out for bid. And so they develop this from their perspective of what needs to happen. Then with the blueprints, a designer gets involved with that, and they may or may not be an engineer, and they're putting the information out there on the blueprint. So it's possibly a different interpretation of what needs to happen. And then by the time you get to control drawings, which are often done by the contractor, that person is probably a designer, but doesn't necessarily have that engineering background. And so it's going to be what I'm going to call a more practical approach, because they understand the controls and what needs to be implemented. And then the last one is the as-built, is when control tech gets their hands on it, they install it and they have to modify it to make things work. So on to the next slide to go through some of these. And Robert, I don't know if you want to just talk a little bit about this.
Sure. Yeah. And I'm sure all of you remember the game when we were kids called Telephone, where you start with a phrase on one end and whisper it in somebody's ear as it goes down the line, and it gets garbled by the end. That can sometimes be what ends up happening with sequence of operation. Starts with the perfect design, but by the time it gets implemented, it's been changed a little bit because of those different levels of interpretation. But this is the kind of language you're going to run into when you're seeing sequence of operation. This is exactly what I would expect to see in a spec book or on a blueprint. Maybe on a controls drawing. Sometimes they do get copy and pasted right down the line, though normally the controls one gets most of that interpretation. So this is the kind of language we're seeing. This is kind of how they lay out. We'll commonly talk about a given system as the higher level and go through the different operating modes. In particular, this is obviously a hot water system sequence talking about boilers. We've got a reset so that we're modifying our supply temperature from a low at 100 to a high at 180. Which is really an interesting span to look at. which we'll talk about here in a minute with boiler temperatures, condensing versus non-condensing. But yeah, sometimes making some notes in the margins about what it's actually supposed to do in this situation, making your own notes, adding notes to your graphics for the sequence of operation, or having a PDF link that people can go to off your graphics can all be really handy. But a lot of times that's the kind of thing we get on newer systems, and adding it to older systems is maybe not practical.
And that PDF thing kind of reminds me of going back to our last discussion about overrides. And if you can document those overrides, some people mentioned they have a notepad that people are supposed to put into, or others have places on their system to do it. But the best way is to get it into the system so that when somebody sees an override, there's a description right there, but that's not always something that's available to do. It's a constant struggle getting things documented, and everybody struggles with finding time to do that. But somehow we always have 10 times the amount of time we have to address it later on. This particular sequence that's up here is actually from a control schedule, so it's on the control drawings, and it's providing us with the outside air reset for the hot water system. And we do have a question up there, Robert. I'm not sure, did you answer that question on the what type of reset it was, dynamic or static?
Oh, I did not answer that question.
Anybody want to chime in as to what that is? Just put it in chat or unmute yourself. Because we kind of covered that last week, right?
We touched on the concept of resets last week, and our main focus will actually be in 2 weeks from now, week 4 of the training. But, a little bit of a primer.
I mean, I'd guess and say it's dynamic because it's based off a variable that's not consistent, the outside temp. But it is a clear setting that stays the same, defining that. So it's tough. Yeah, I'm not sure.
Good observations.
You want to hit that, Robert, or should I?
Yeah, I got this one. So from my perspective, this is what I would refer to as a static reset schedule. It's got a hard top and a hard bottom, and it's referencing what is basically a single variable, our outside air temperature. Dynamic resets, or what is sometimes referred to as trim and response, is looking directly at a whole stack of variables within a building. For hot water temperature, it could be zone error, or maybe hot water valve position, or a combination of those two. So it's a much more variable target. So sometimes we refer to those as dynamic resets. So this one would be a static.
Yeah, so they're basically the dynamic. The way I interpret it is that it's changing the parameters, maybe in this case, maybe max and min, that you're adjusting your temperatures within to meet the space needs. Okay. Next slide. So here's another sequence of operations where it's talking about same hot water system. How are the boilers going to be sequenced? So we have, in this case, it's just not one boiler. There's 5 boilers we need for the building. And they set the speed on the pumping because each boiler requires a certain amount of flow and pressure to operate correctly. And they've sequenced the VFDs on the pumps in this schedule here, 1, 2, 3, 4 boilers, but there's 5 boilers. And this is obviously, and Robert, correct me if I'm interpreting this incorrectly, but this is a static reset where it's just getting input as to how many boilers are on, as to where it's going to operate. But if you look at it, think, well, okay, so it's at 100% flow, it's meeting a need of 4 boilers or 5 boilers. Is that correct? And it may meet the needs of the systems and not get you out of the range of operation for the boilers themselves, but it's not addressing necessarily the most efficient method from a pumping standpoint, and it possibly may be impacting your water temperatures. And so there's probably a better way to do this, more geared towards the dynamic concept, where you're looking at not just how many boilers you have on, but your temperature differential between supply and return, and or pressure in the system to meet the need of the boilers, as well as minimizing the energy use of the system as a whole. So that would be a good way to look at that. So sequence of operations can have a huge impact on energy, just depending upon how it's set up. In this case, we did look at some commissioning aspects, and they're in the process of changing this setup to do exactly what I just made a comment about, looking at temperature differential and also the quantity of boilers on to make adjustments and maintain a proper setup for the system. So also for the sequence of operations, you look at, okay, looking in what else it does, indoor air quality or indoor environmental quality. And the difference, by the way, for indoor air versus environmental is that indoor air quality deals with just the air aspects. So when you're looking at the air and say inside your room, what do you think the major pollutant source is in a building? Anybody want to take a gander at that? Just put it in the chat or raise your hand.
I know. Pick me.
I know people produce a lot of CO2 or whichever, so you have to have makeup air as code requirement now for a lot of buildings for
And
quite some time.
That's exactly right. In most buildings, the primary pollutant are us, people, because we're constantly breathing. That means we're bringing in oxygen and exhaling CO2. CO2 is a pollutant. It can create issues for us from a sense of being awake and or attentive. It impacts our productivity. So that's a big concern. Plus also as humans, we're bringing in different types of
Viruses, all kinds of things.
Yeah, I mean, we're shedding skin constantly. I forget the numbers of cells that we're shedding every minute, but it's phenomenal.
I guess my second would be stagnant air and moisture leads to mold, which also hurts the people if we're talking about pollutants and stuff. And then we'd have to determine what type of system to go after that, whether it would be leftover gas or what have you.
Well, and, stagnant air as a whole, and that leading into the mold issue can be a whole different set of control issues that you need to address, right?
Oh yeah, I've been tasked with balancing our system to figure out the highest I can set the system without having mold issues. Set the system back, that is, I should say, this summer. And it's going to be, a balancing act. But we've started adding a lot of VRF systems, and it was requested that I see what I can push those to. But I'm a little nervous about those.
Air movement goes a long way in evaporating moisture and keeping mold at bay. But then you also have to think about removing that moisture somehow, somewhere.
So I actually had, when I was a facility manager at a museum, I had an inline humidifier because the artwork was made of wood and had to have a higher humidity than most buildings required. And it was about 60%. So it was up there.
Yeah, the museums are often very difficult to control for that reason.
Yes.
the issue becomes is that somewhere in the upper 50% relative humidity range, and especially for like a library, that's where the paper absorbs enough moisture and you got to worry about mold.
Right. But if the artwork, if the carvings didn't have moisture, they crack. And
Yes.
they're not artwork anymore. They're in pieces.
So
So it was definitely a balancing act. The other thing I discovered too is your traditional fluorescent tubes that are all in the cabinets produce a lot of UV, enough to damage the artwork. So
Yep.
they were staining these, they were damaging this artwork by having these lights shining on them 12 hours a day.
Yeah.
Yep.
We're learning a lot of things, and we're finding new ways to test for issues as we progress in our technology. And these all are leading to findings on ways we can do things better.
As long as we keep the science in it, that's all that matters to me. Just keep the science in.
Yep. Yeah, it's critical. You know, it's just amazing how much has changed in the 40 years that I've been around in this industry, in our ability to measure things, and it just boggles my mind. So you know, those are environmental things. The environmental aspect also looks at lighting, and lighting is really important because our bodies react to light. You know that if you all of a sudden gets brighter, you squint, your face contorts, and you can actually wear fatigue based on that, and people get headaches from it. The other aspect, if it's too low, you have issues. You have outside conditions such as the sun coming in, and maybe you'll use that to help you out with lighting. There's noise, so you have to look at if you have VAV boxes that are constantly backing off, closing a damper, you might get a lot of velocity noise in those VAV boxes, creating issues for you. And so duct velocity is a concern, and we have aspects in our controls that we can deal with that. Ergonomics, which really isn't for us as control techs, but for people in the space, that's part of their environmental quality. And comfort. Comfort's a big one that we are providing to people in this space, temperature and relative humidity. Anybody know what the definition of comfort is in a space? Well, it's going to be, go
Are you
ahead.
talking about like the ASHRAE specs or?
Well, if you want to go to ASHRAE, you can.
But I'd have to pull my notes on that. I know it's close to our set points, but I know it's changed since I looked at it. My ASHRAE book's a little older, I think.
Yeah, so ASHRAE, they developed this comfort range back in the from data from the 50s, and they have modified that recently as in the past 20 years, to accommodate a lot of different changes. But the original studies were based on people in spaces without clothes on, and they would see, okay, when somebody comfortable, when somebody not comfortable. So it's kind of an odd measurement, but they've refined it. It's much better today than it was, but they still look at comfort as meeting the needs of 80% of the people. So there's still 20% that aren't satisfied. And as building operators, we got to make sure everybody's satisfied, right? So it's kind of a odd standard to go to, but comfort by itself is a definition where you don't feel heat or cold in the space. There's no sense you have of that. So it's a matter of you're comfortable in the space because you don't have cold spots or hot spots that you're feeling. You're effectively equilibrium with the space. So that's comfort. And you think about it for yourself, that's kind of how you define comfort. Oh, and Tony's bringing up that there's summer versus winter for comfort ranges in ASHRAE, and yeah, that is true. Our bodies react to different types of environmental conditions. So something that our sequences have to take into consideration. Good to point that out, Adam, that ASHRAE refers to the American Society of Heating, Refrigeration, and Air Conditioning Engineers. And they're looking at 68 to 79 degrees as a comfort range. And they do have two different ones for the summer versus winter too. Okay, let's move on. Go on to the next slide.
That
Oh,
was
Robert, this is
my
yours.
fault. I got too much there, so let's go ahead and slide past that one, Ted.
All right.
All right, so let's talk about a little bit of sequence of operation. We're not going to totally beat a dead horse here, but we do want to talk just a little bit about some common sequence ideas in different systems. So here we are looking at a hot water system, 2 boilers, 3 pumps, heat exchanger, you know, really a pretty standard type of system. And, you know, if we break this into a couple of pieces, our common sequence of operation for boilers nowadays is we're going to change our desired temperature coming out of or returning to the boilers based on outside air temperature or load in the building. And when we are using outside air temperature, really we're just trying to guesstimate what the load in the building would be because of the outside air temperature. So they're really kind of shooting for the same idea. But we're also going to change the speed of our pumps based on the load in the space. And we typically do that using a differential pressure on the hot water system. The more valves are open, the lower the pressure will be, so the pumps speed up to match it. Now, I said earlier that I thought that reset sequence on the boilers for that sequence of operation we looked at a couple slides ago was really interesting because depending on what type of boiler you have, it will really dictate what temperature range you want your hot water system to be operating in. Because when you're getting water into your boilers that is below 140 degrees, we start having condensation in our flue gases. And that condensate, as I'm sure many of you already know, is acidic. So it can potentially damage the wrong kind of heat exchanger. You know, if it's an older boiler with cast iron or steel or something like that for the heat exchanger, the acids will wear away at it and you'll get holes in your heat exchanger prematurely. Our newer boilers, our condensing boilers, are designed to deal with that condensing flue gas and that acid, and often have stainless steel heat exchangers in them, specifically to address that problem. Or part of the heat exchanger is stainless steel, depending on how they have things set up. And that particular sequence, we were resetting our temperatures between 180 and when it's really cold out and 100 when it's warm out. And that changeover point is about 140 degrees for natural gas. So it's possible that system isn't running natural gas for the boilers. That's a possibility. But more likely they have a mix of what types of boilers. Because your condensing boilers gain their efficiency below 140 degrees. And as we already said, your traditional boilers don't like water below 140 degrees. So,
and the other thing about that, Robert, is traditional boilers are typically most efficient somewhere around that 70 to 80% load point, whereas a new condensing boiler is going to be really efficient at very low loads. The lower the load on the boiler, the more efficient it is. So the thought process is you want to have as many condensing boilers operating as you have available and meet the load, but not go below their poor operating point, which might damage the boiler setup. So, and that 5 boiler example I gave earlier, we look at trying to put at least 10 to 15% load on each boiler and stepping them up, because we want to make sure that we have as many boilers on as possible to maximize our efficiency.
Yep, absolutely true. And exactly why when you have a series of condensing boilers running a system, you'll often find multiple of them running at fairly low percentages because of that efficiency.
If they're set up right.
If they're set up right. Next slide, Ted. And remember, if you've got questions, ask them, because we're going to kind of roll through this a little bit quickly so we can hit our break. But if you got questions, please stop us. So now we're changing over from our hot water system to our chilled water system. Obviously, this does not apply to at least one of our groups of friends up there in Alaska. So just bear with for a minute, but a lot of the principles are still going to be the same. Unlike with our hot water systems, it is significantly less common for us to reset our chilled water temperatures based on the outside air temperatures. For us, most of the time, chillers are just on or off. They're designed to make certain temperatures of water. And when you start changing those, you run into problems, as we've previously discussed, specifically with that surging effect on chillers. That is becoming less of a problem, kind of. Our newer chillers are often more tolerant of differing temperatures and have more of the capability of adjusting themselves to a given load. So we're seeing less surging, but there's some caveats there. Our pumping systems in chilled water very frequently operate in the same way as our hot water. We're going to have VFDs on our pumps that are going to ramp up and down to satisfy the pressure needs within the building to make sure that we get what we need where we need it. But that being said, in smaller buildings or older buildings, it is not at all uncommon to find constant volume chilled water systems where you have a lot or at least a certain number of three-way valves or bypassing valves, and pumps that are just on starters, so they're constant volume. We always have enough flow through the chiller. It works really effectively, though we may not get the best temperature delta, or we may not use as much chilled water as is best for the chiller to come back to. We may have small differences between our supply and return, which can also cause problems for the chillers. But it's one of those give and take things. With certain sizes of systems, it becomes challenging to maintain minimum flow to the chiller in certain circumstances. We also may have separate heat exchangers. This particular system here on the right-hand side, just to the right of that big note, you can see a heat exchanger between two pumps. This is something that we are seeing more and more, where we have systems that can take advantage of our condensing water side to directly cool our chilled water loop. This is when our outside air conditions are still fairly cold, typically above freezing, so that we don't freeze up our cooling towers. But, you know, there is enough load in the building that we still need some chilled water. So we do this as a way of an alternative to bringing in cold, fresh air that we may have to do other things to make acceptable for our space. That being dehumidification, which again requires chilled water, or DX cooling, or it may be a filtration issue, air quality, things like that.
And I've actually seen one of those loops, Robert, operating at 0 degrees outside conditions.
Wow.
And the reason for it was they had this 11-story building, and on like the 5th and 6th floors, they had a catering operation, so they really high internal gains, and they needed to remove that heat. So they were, and it was a water heat pump system in the building itself. So that loop was being cooled by that cooling tower so that those areas could maintain more comfortable conditions. But it surprised me when I came up to the building and the cooling tower was operating.
Yeah, the only time I've seen cooling towers operate in particularly cold weather for climate control purposes. You do definitely see cooling towers working for manufacturing reasons, but for cooling reasons, it was a really interesting winter, and the building was still under construction, and they were running the hot water loop completely wild, so every box basically had full hot water all the time, and they actually had to do that to keep the cooling towers from freezing up that winter. It was a huge waste of energy, and I still have yet to hear a good explanation why they chose to do it that way. But it was the general contractor's call, and that was the way it happened. Questions on our water systems there? All right, next slide, please, Ted. All right, air handlers. Air handlers are complex, to say the least. Generally speaking, the job of our air handler is going to be one of two things. Either we are taking care of a large zone directly with the air handler or rooftop unit, or we are supplying primary air to some other form of zone control. So we're bringing in fresh outside air, assuming our conditions are acceptable. We may be bringing in more or less. When it gets particularly cold outside, particularly hot outside, or humid, we may bring in as little as possible. And if it gets hot enough or cold enough, or the air quality is bad enough, we may need to shut off our outside air completely. But oftentimes those are going to be your driving factors. We're going to try and maintain kind of cool air coming out of our air handler at most times. So we're going to use that to dehumidify our space. We're going to have a mixture of return air and outside air, pulling air back out of our spaces so that it can be filtered, so we can get rid of those that carbon dioxide, those other volatile organic compounds that we release as humans, that some of our equipment releases, stuff like that. Hot water valve and chilled water valve will work in conjunction, typically to do our final control of our supply air temperature. Again, most of the time we want to be somewhere between pretty cool and maybe not very cool. Kind of 55 to 65 is common temperature ranges to see. 55 when we are looking for cooling in our spaces, 65 when we are more in a heating mode in the majority of our spaces. We vary our supply fan speed to maintain our airflow again to our spaces, getting that fresh air to them, making sure we've got conditioned air going to them. And typically we control that using duct static pressure. Return fan can control any number of different ways. It can track to our supply fan with a specific offset or specific airflow offset, so that our return fan is always keeping up with our supply fan, keeping up in quotes. We may also control our return fan off of different pressures within the building, either within the return ductwork, within the mixed chamber there on the left-hand side of our graphic, or off of the building pressure itself. Though oftentimes we will also control our exhaust air or relief air off of that building pressure. So it's one of those things. There are a lot of different ways to control a return fan. Supply fans, we're pretty pretty solid on how we do that. It's pretty universal. Sometimes you will have humidifiers built into your air handlers, depending on your climate zone and your needs within the building. Those are going to operate to maintain usually a minimum supply humidity, but actually trying to control our space humidity. So it's kind of a juggling act there. And sometimes we will have specific sequences for dehumidification of air, especially for the folks up or down in Florida, North Carolina, where you get a lot of humidity. Those are often sequencing items. Ted, what am I forgetting here?
I think you hit most of the items.
Cool. When's lunch? Oh, no, that's not the question right now. Sorry. Anybody have any questions? Charles.
Yes, for a water-cooled chiller, what is the common shutdown sequence? Is it air handlers off, pumps, then chiller, or is it the opposite? Chiller, command off, and then air handlers pumps.
Oh, that's a solidly tough question, Charles. And it can definitely be done both ways. As far as the equipment order goes, it depends largely on how your chillers are sequenced to maintain flow. Because anytime we're turning our chillers on or turning our chillers off, one of our major concerns is maintaining flow so that we don't potentially damage the chiller by causing a freeze up of the water that's flowing through it, with or without glycol. So it really depends on a lot of different things. Personally, well, yeah, I got to be careful with this. If you have a way to maintain the flow of chilled water without your air handlers running, then it's okay to shut those off first. And the chiller will naturally cycle down as long as it's capable of doing that while you are shutting it down as well. The one thing that I personally never allow is for the pumps to shut off or the valves, isolation valves, to close on the chiller until it has completely shut down. That's the most major one for me, no matter what type of system you've got. Ted, what are your feelings on that one?
Sorry, I was a little bit distracted, so I didn't quite catch that last bit.
Not a problem.
So answering the question.
You're taking care of the chat. Awesome.
Yeah.
Did that give you a waffly enough answer, Charles, to be completely useless?
No, I think that was a good answer. But I was in a meeting yesterday and that discussion came up about shutdown sequence, and it was kind of like what you said. It was kind of both. Some people thought one thing and then the vendor thought something else, but I guess it just depends on what you said about the flow.
Yeah.
Yep.
And if it comes down to a discussion on it, listen to the chiller manufacturer, their representative, because let's face it, as much as we talk about energy, the cost of energy is relatively small in comparison to having to replace a chiller. So they're kind of the king of that, of most conversations in regards to their equipment.
I think the one thing that came to mind when you first started describing it, Charles, was that the sequence really for the chiller system is typically independent of the air handlers. They're not necessarily linked. Is that not true, Robert?
Yeah,
So
most of the time we either turn our chillers on because of a specific outside air temperature, or because we're starting to need that chilled water at our major devices like our air handlers.
and so maybe you're just including the air handlers in that discussion or example of it, but didn't necessarily need to. I'm not sure. That's one thing that came to mind when you first described it.
Antonio.
Yeah, hello everybody. Well, thank you for putting this together. I put it in the chat, but I really want to punch this. So we have most of our schools along the coast, whether it's down here in the Rio Grande Valley or Houston or Jacksonville or Tampa, in that area. And I've seen just so much variation on the sequence of operation. We don't have a lot of chill water systems. That's a whole separate discussion. It's for risk mitigation purposes on our school. We typically run individual RTUs with outside air intake, which is, again, not optimal, but nonetheless, that's our reality. And what I really wanted to understand is like, I've seen some sequence operation associated with the fan mode, where some are on auto. Whenever the space is satisfied, it'll shut off the fan completely. And some that are on continuous, which there's a whole things that need to be right. If you're on continuous, space is satisfied, compressors turn off, damper positions will go to min or close completely, which at least supposed to close, but the fan continues to run. And so when that happens, we bring in a ton of humidity into the spaces. And I just wanted to get your thoughts on what is the pros and cons of having fan mode to be continuous versus auto? Because I'm this close to just making everything auto.
Yeah, Robert, let me step in before you address it, okay? First of all, for commercial buildings, which schools are, the code requires continuous airflow. So technically it shouldn't be an auto. However, a building operators has leeway in how they want to operate the facilities, but if any issues ever develop where you're not running in continuous mode during occupied periods, there might be some liability associated with that. You probably got to talk to or figure out the local code and state codes applicable to you, but that's something I would think about. So generally, when it's commercial building, you need to have that system operating continuously. Having said that, I can't tell you how many different small shops, retail outlets and stuff I've been in where that's not happening. So it's commonly done. But that's something to think about. And the moisture issue, you got to bring in outside air to meet the needs of the code requirements for those areas, and to keep the indoor air quality good for people using the spaces, especially in schools, because if it's not a comfortable and good indoor air quality, you're going to see people having issues. There's going to be more sicknesses, absences. There's going to be lower test scores, the whole shebang. So you have to pay attention to that. So having said that, you want to figure out ways to be able to operate continuously, but minimize your outside air intake. I'm gonna let you take it over from there, Robert.
Can I ask a clarifying question? I mean, we're using demand control ventilation with CO2 sensors out there. So, I don't know. I don't know the specifics of ASHRAE, but I was under the understanding that as long as you have demand control ventilation, then you are satisfying the codes. Not sure. You know, I'm not an expert, but that's typically the way that we determine the outside air intake.
So yes, that's a really good way to do it. But that's just allowing you to not bring in design outside air flow. It's allowing you to back off on that according to your CO2, which is coming from your major pollutant, us, in the space.
Sure.
It does not, again, allow you to turn the fans off. So does that answer that one?
Okay, fair enough.
Yeah, and it's usually, you have to be a certain parts per million, which is how they measure CO2, above ambient. And ambient these days is around 400 parts per million. And you have to be, I think it's 700. Is it 700, Robert?
I think so. We have 1,000 parts per million as a
Yeah.
spec, which is 600 above ambient typically.
So that's maybe being a little more stringent, and that's okay. And as long as you're not going over that limit, then you're okay.
So to build on what Ted said a little bit there, so that demand controlled ventilation may allow you to control your outside air dampers a little bit more effectively for your needs. But yeah, again, technically we do still need to keep those fans running to keep the air circulating. And a lot of times you'll end up with complaints if you don't in those type situations. And I know you were calling out the outside air damper portion as a big part of your problem with these units. And I would tend to disagree, more so because that DX cooling aspect becomes very hard to manage without overcooling your spaces. Chilled water is a lot smoother to control
Sure.
in those applications. But you know, it really absolutely is a cost thing. And you get, especially at this level, you get what you get, and you know, that's it.
Yeah. And I have that running in unoccupied modes in some spaces. You know, the fan on in unoccupied modes as well, which is again
That definitely shouldn't be necessary. Not in unoccupied mode unless there is, you know, some sort of extenuating circumstance. But most of the time, unless it's something like maybe some sort of lab situation where you've got something that you do need to ensure fresh air because of, unoccupied mode, you shouldn't need to be running the fan continuously in most situations.
got it. Thank you for the guidance. Appreciate that.
Yeah, and so just one more thing on that, you want to make sure that before you make some of those changes, you find out why they had it set up to operate continuously during unoccupied or whatever, because as Robert said, there may be some reasons. So it's good if you can troubleshoot that ahead of time. And if you can't, and you do change it so that it only operates when you definitely need it during off-peak periods, you need to pay attention to it for a little more attention to it, begin out with, make sure that it doesn't develop a problem. And one problem might develop is mentioned before, where because of the moisture content being by the coast, you might have some mold issues that develop if you don't have continuous airflow in that space. So you have to think about that aspect.
So we do have one question more here in the chat, and after we do this question, I think we're going to take our break. But this is specifically related to fan walls. They're starting to see those in their newer installations or newer replacement equipment at the air handler level, and that doesn't surprise me in the slightest. So if you go back historically, our oldest air handlers that needed to move a lot of air had giant fans that were controlled by DC motors. And we use DC because we could change the speed of them. And I really am meaning old equipment here. You know, we're talking, you know, like universities that were built back at the turn of the last century, not this one. That were using this type of equipment. They were able to control the speed of the fan so that they could get the amount of air they needed. As time moved on, we started using more AC motors, and different control strategies for getting that amount of air. Things like inlet dampers would be a good example of that. And then we started using variable frequency drives to change the speed of the motor itself, so that we didn't have to try and control the airflow. We could control the motor directly and be much more energy efficient. But we were still typically running these large monolithic fans. If you had a unit that needed 100,000 CFM, you had a fan that was taller than you were. But that's changed in, last 20 or 30 years, more or less. And we've started seeing these devices called fan walls, which really from an operations standpoint are a lot like our condensing boilers. Instead of having one giant boiler that just does everything, we have multiple that share the load. And that's the idea behind a fan wall, is we have multiple smaller motors, smaller fans, so we end up more power efficient, and we spread that load so that, again, we end up moving the same amount of air, but using less power in the process. And oftentimes, one of the other big advantages to fan walls is if you have a unit fail, it's just one fan. So if you've got two fans, you still have at least 50% capability. You may have to go block off that one fan that's not running so that you don't, short circuit the airflow. But it's possible to do, to continue operating. Whereas if you only have a single fan, when that motor goes down, you're stuck. And fan walls, I've seen fan walls that have had as many as 24 motors and fans that were operating, and 3 backups on that particular system. That's the biggest I personally have seen. I've seen systems as small as 2 fans. One of the other advantages or common things that we see with fan walls is we use direct drive motors and fans instead of having our traditional belt and pulley systems where we have that additional maintenance item. We have more bearings, things like that. These are direct drive, so we have less of those failure points. They can be really, really effective, and I would absolutely expect to see more of them. One of the challenges behind them is they're a little bit complex on the electrical side. Running multiple motors off of a single variable frequency drive means that those drives have to be set up in a very specific way, and that you have to have the correct overload protection to satisfy the electrical code to protect your motors. Ted, anything to add on that?
Yeah, I've been seeing them go in, replace those older systems. 1920 building, we've seen, and we're continuing to replace. There's half dozen, I think they're like about 70,000 CFM units that they're doing that to. And it's really effective, and it's really cut down the power consumption, going from this was 3 years ago when 4 years ago we started looking at it, but it's like 100 some horsepower motors down to, I don't know, about 15, 5 or 10 horsepower. And since they're on freak drives, they're really low. They're not using much at all.
Yeah.
Really effective way of doing it. It's also helped with controlling the air in the spaces better. So a lot of pluses to it.
So I have to ask, Ted, where were these fans that you were seeing this being done to?
You want to guess? They're in the basement.
They're at MATC?
Yeah, they're at MATC. They're in the basement of a 6-story building.
Gotcha. I was just curious because I know where you're at, and it could have been University of Wisconsin. And the place that I saw that monolithic old DC motor system was at University of Wyoming. So both UW in different parts of the country.
Yeah. I'm also, we also see them going into another area where it's 1970 vintage building replacing the system. So
Fantastic. Just a quick call for questions. All right, if you have any questions, hold on to them. We're going to go ahead and take our break. We're going to take a 10-minute break here, or actually we'll make it a nice even number when we come back at 20 minutes past the hour. So you get a 12-minute break.
And welcome, Aaron. See you able to join. That's good. All right.
See everybody in about 11 minutes.
Hey, Ted.
Sounds good.
All right, folks, welcome back. Hope your break was as satisfying as mine. Continuing on with our sequence of operations. So we're going to touch on, we have one more we're going to talk about and one slide we're going to skip because we are running just a little bit long. Not that the conversation hasn't been good and well worth the time. So what we're looking at here is a zone control device. This particular one is a VAV box, or variable air volume. And this specific example is also a parallel fan powered box. VAV boxes of a number of different types are exceptionally common in commercial buildings. I know in some areas, a lot of schools kind of tend to prefer water source heat pumps or fan coils or unit ventilators. But VAVs are still a big item and kind of coming back into phase in a lot of buildings, including schools, because they are very effective at their job and can be very low maintenance. So general concept with a VAV box is we have primary air coming in on the left-hand side from our air handler or rooftop unit. This is going to, again, be kind of typically cool air coming from there so that we aren't worrying about dehumidification with it. It's already been dehumidified, a little bit of preconditioning, and it can be effective with cooling off our space that way. We rely on our reheat coil there in the middle. This particular one is a hot water reheat coil, but they come in a number of different varieties, including steam and electric. We rely on that to heat the air back up as required to maintain space temperature under heating loads. This does run into a little bit of a challenge potentially with simultaneous heating and cooling. We're cooling the air off at the air handler only to heat it back up at the end zone. That is one of the potential challenges with VAV systems of this particular type. So one of our goals overall has to be to kind of minimize that. One of the other challenges with reheating the air coming out for a VAV system, and this is a pet peeve of mine, which is why you get to hear about it right now, is overheating that air. This is really easy to do with our higher hot water temperatures and with our steam temperatures, and actually our electric reheats as well. You have to be careful and not to overheat the air coming out of a VAV box, because if you do, especially if it is for a smaller space, we're going to have some issues with that air clinging up at the top of the ceiling. If we don't have the velocity to get it down where the people are, it won't do an effective job of heating. So we do want to try and keep our air coming in from the VAV, even when we're trying to heat the space, somewhere below or kind of around 90 degrees. 90 degrees does a really effective job of heating up the space, but it also does a good job of mixing with that air that's in the space already. Excuse me just a second. All right. Now, fan-powered boxes, as we discussed last week, have the additional complications of having fans and filters with a parallel fan-powered box like this. So what it does, as Ted's drawings can help us see the airflow pattern, is that parallel fan will pull air back from the zone itself. Basically, a little miniature return air. Pulls it through a filter. You can see one there on the right, and you can see where one is completely missing on the left. You know, sometimes that absolutely happens in the real world. Those filters do have to be changed. It is a maintenance item. If you don't change them, they turn into carpets and either don't let air pass or become the lunch of the fan. And then you get an unbalanced fan that makes a lot of noise and people complain about it. And then you have to go fix the filter and the fan. The other challenge with these from a maintenance aspect, obviously, is that fan and the motor. Motors fail. Fans typically have some level of maintenance, though we are seeing a lot more of the maintenance, quote, maintenance-free versions of these fans where there's no bearings to, or where the bearings are permanently lubricated and we don't have to do anything with it until it fails. So that is one of those advantages. And again, the big advantage with parallel fan powered boxes is in the middle of the night when your air handler is shut down, you can use that return air and the reheat valve without the primary airflow to heat the space back up. So it can be really energy efficient from that perspective. Okay. But this is one of our major items for zone control. Anybody have any questions on that or anything I missed, Ted? Thank you for the lines to help illustrate flow directions.
I just want to emphasize again that, you know, it's a fan powered box. You have more equipment. There's more maintenance. You got to be aware of that.
Yep. All right. And I lied, I'm not going to skip the next slide, Ted. So if we could hit the next one.
So you said you're going to skip the next slide?
No.
Okay.
All right. And this is a fan coil. And the reason I decided not to skip this is because they are very popular for use in schools. So skipping it would be inappropriate, I think. Fan coils often operate as miniature air handlers, with the exception that they don't typically have outside air. They will receive a certain quantity of fresh air from a dedicated outside air system. So that system brings in fresh air and kind of injects it into the return path as preconditioned air. The big thing with that preconditioned air is dehumidification in the summertime or tempering it, warming it up a little bit in the wintertime. Because the fan coil units only have a certain capacity that they can work with. But generally speaking, fan coils are both simple and complex at the same time, if that makes any sense. In our drawing here, our illustration here, our airflow is from left to right. We've got return air coming in. It goes through a section of filters, goes across a coil. In this case, we are using what's called a two-pipe system. So this is either a dedicated cooling only, a dedicated heating only, or a system that swaps between the two. And I'm sure with the number of folks that we've got here, somebody out there has a two-pipe system in their school and probably has words that they would like to say about that system that, you know, might qualify as adult content. They're not very popular. They are problematic because you cannot have both chilled water and hot water in the same day. And typically it takes several days to do the switchover. during which time nobody is happy. But anyway, we go across our coil to either raise or lower the temperature of our air, and then we have our fan motor. A lot of times these are, in modern fan coil units, are being used with ECMs, or electronically commutated motors, which is basically a small motor's solution to variable speed. They can be very, very efficient, very quiet, and very long-lived motors. Typically speaking, they are also going to be used in a direct drive system. This particular one that we are seeing here is probably of an older design, where we are still using a belt-driven motor so that we can change our shivs out to adjust our speed, and is probably a constant speed motor, no variable frequency drive or anything fancy like that. But we draw air specifically from the zone that we're trying to control, be it a classroom or a cafeteria or something like that. And then we discharge it out on the right-hand side after we adjust it as much as we can and or need to. A lot of times these operate as almost constant volume systems. The older systems really were constant volume. You either had on or off on the fan. And during occupied times, you basically ran the fan. It let you filter the air in the classroom and condition it in the same space. With our newer systems, the ones with the ECMs, we have that variability, and our motor can ramp up and down appropriately. So when we actively need to heat or cool, we're going to speed our motor up, much more so in the cooling phase, obviously. But when we are occupied and just want some basic air circulation, our motor ramps down and we just circulate a little bit of air. Whatever we need to maintain that fresh air requirement or that air circulation requirement as appropriate. That's pretty much it with these. Again, they have a little bit more maintenance than your basic VAV box because, again, we've got filters and we've got a fan and motor. If it is a belt-driven motor, obviously we have belt maintenance. We may have bearing maintenance, things like that. If it's direct drive, it's much more likely to be, when it's broke, come replace it level of maintenance.
Yeah, I just want to make a comment about it too. Every time you have a motor inside the airstream, you're picking up heat from that motor. So you might get a degree or two rise off of that motor. Just to be aware of that. And control wise, I've seen where, not necessarily on a fan coil unit, but could have been, but air handlers where this one school district I was involved with, they intentionally controlled their mixed air temperature set point, which I know we haven't got too much into that yet, but mixed air temperature set point separately from the discharge air temperature set point. And their intention was that they put a 2 to 3 degree rise, at least that's what they told me, 2 to 3 degree rise across that from mixed air to discharge air to avoid coils freezing up in the winter time. In the half dozen buildings I looked at, that temperature difference wasn't just 2 or 3, it was 4 to 6 degree difference. And I did a calculation for that district based on what I saw. Well, I adjusted it down to their 2 or 3 degrees. And I came up with about $400,000 a year cost for all the extra heating they were doing unnecessarily in the systems. So that can be an important aspect. So when we're looking at our controls, we want to make sure we look at energy conservation and don't intentionally put in control points or set points that tend to waste energy.
Absolutely.
And so that $400,000 extra cost a year was really because they had a school or two where they had $30,000, $40,000 of damage caused by a frozen coil over the past half dozen years. So it's a very expensive fix to the problem when they really should just fix their freeze stats up, in place where it's freezing temperatures outside, you put a sensor on the discharge side of the heating coil to shut it down and turn off the fans and close dampers whenever temperatures go below a set point, which is typically around 36 to 38 degrees. So
You
just
may
a comment.
also have heard those referred to as low limit thermostats.
Yeah.
They try and dissuade us in the industry from calling them freeze stats because the lawyers get scared of words like that, basically.
Hadn't heard that one, but I'll be more careful in the future.
Colloquially, they are commonly referred to, however, as freeze stats because that's their goal is to prevent systems from freezing up. Now, there is a cousin of the fan coil unit, like we see here, that many of you may also be familiar with, and that is the heat pump. Heat pumps operate very similarly to the fan coil units from a sequence standpoint. The big change is we change over that refrigerant or that hydronic coil like we see here with a refrigerant coil and compressor combination. Most frequently, we see these paired with water loop systems. They can be geothermal based water loops, or they can be just cooling tower and boiler based water loops. I have seen both in Nebraska, where I previously did most of my control work recently. Geothermal was very popular for this type of setup, and especially in the schools. One of the 2 largest school districts in the state actually made it their basis of design. So when they built a new school, it was all geothermal temperature control using water source heat pumps, which can be very effective, is very energy efficient, but you really have to be on point with your maintenance, your preventive maintenance with it. So.
And the other issue from that from a design standpoint, especially if you're considering retrofitting, is that it requires coils in your systems, your heat exchangers that can handle what tend to be lower temperatures on a heat pump system as opposed to a normal hot water system that uses boilers. Because the heat pump systems, what are their higher temperatures? The highest temperature you typically get in a heat pump, 160 maybe, Robert? Do you remember?
Yeah, maybe. That's a pretty high temperature for a
heat
pump loop.
Yeah, so you have to be careful about that. There's been a number of buildings in the Wisconsin area that are heat pump buildings. I can think of 2 that are in the Madison area that are there and operating just fine. And I know that the school that I work for, Milwaukee Area Technical College, retrofitted our North Campus with a heat pump system that's a geothermal setup, and it works pretty good. They're slowly replacing the coils in air handling units with larger coil setups to get the better heat transfer. So that process is taking place. They put in a number of fan walls, as we discussed earlier, but as a result of being retrofit and not having all the coils being able to change those all out right away, they put in what I call topping off boilers. So they have the geothermal system providing the heat, and then at the very end, just when it's colder out, they bring on boilers to bring the temperature from whatever the heat pumps can do up to 160, 170 degrees for cold weather. Pretty effective system.
Anybody have any questions on fan coils or heat pumps, or more generally, sequence of operations? So, yeah. That puts us on to our next topic, which is a little bit less of Ted and I talking and a little bit more of you folks.
So we'll go back to discussion of overrides and things that you've encountered. We've had earlier quite a discussion on what other people have seen, what they gathered from their homework. And we're going to give you a couple ticklers here to get you talking about some more areas. And these are some, there's basically, well, I guess it's not on this one, is it? Okay. There's overrides that we do as building operators, which are external to our control system. And this is an example of some of those overrides where somebody has pulled the disconnect, turned it off. Whereas one air handler, number 107. And in the other example there, we see that somebody's disconnected the linkages. This particular picture is from a building where I have pictures of at least a half dozen air handling units that had the damper actuators disconnected from the linkage so that the outside air dampers didn't operate at all. Big issue, big problem, and this is more common than one might think. But those are quote unquote overrides that you might encounter. So does anybody else have any other ones here? I know we have some listed here where people just bypass the frequency drives, disconnect wiring. Anybody else have some things they've seen?
I can start us a little bit. One things we've seen is people removing two-way valves or removing actuators on the two-way valve so that, then a heat pump essentially becomes a strainer and there's always flow going through the heat pump rather than closing them off if they're not needed.
Yeah. Yeah, and I can't say I've seen that one, but I'm sure it happens quite a bit.
Oh, I have. I can't
Yeah,
count
Robert?
the number of times I've seen that one.
Yeah, then pumps are just screaming and you don't have yeah. It's a lot of
it's
fun.
re-
Well,
yeah,
when you do
it's
that
real
on two,
waste.
what was that, Robert?
A real waste.
Yeah.
Mhm.
And if you're doing that on a water system that has a frequency drive, so you have varying flow rates, now you just taken away the ability to flow water, vary the flow of water through that particular heat exchanger. If you do that in all your units, now you've taken a variable speed water system, made a constant speed, and you've taken away all this energy savings. So it's a issue that as control people, we need to be aware of, that we don't interfere with it. I'm seeing a number of things in the chat, Robert. We have
Yeah, we do.
seen putting drives in hand, the VFD drives, which that's a very common thing.
Yep. Chilled water actuator that's been disconnected, just hanging, very similar to Tyler's two-way valves on heat pumps.
Yeah, and I've seen, I guess I have seen what Tyler said. I've seen it at a post office where they basically just opened up the chilled water valve 100% to get what they wanted.
Yep. Bypass valves on air handlers, sometimes I've seen those utilized. So they're bypassing the control valve with a ball valve or, some sort of hand valve. So I'm curious, Aaron, on yours, you mentioned the actuator position is flipped. Now, I'm curious, is that itself the override, or was that the cause that made someone make an override to deal with that potential issue?
It's kind of been the latter of those two, and just kind of something that I tend to play around with in the building automation system. Like, oh, this valve is at 100%, but the input temperature is the same, is different from the output temperature or something. So I'm like, okay, well, maybe the valve is slipping. And then you go on site and you realize, nope, 100% is actually 0, and 0 is actually 100%. So not sure how it gets to that place. Like, maybe it was installed incorrectly, or maybe it was repaired. Maybe the valve, maybe it was slipping, and in that repair, it was positioned the other way. But I've come across that more times than I'd like to in the field.
Yeah, I've definitely seen that one as well. And I think you've hit on both of the major reasons why that happens. Either it was something that was misinstalled and not caught during the initial construction or renovation project where that valve was installed, or someone went and did a repair. Maybe they had to replace the valve and just put the actuator back the wrong way, or put the actuator on upside down, because some of those are reversible in that manner, or just got the wrong valve for that particular application. Those type of errors absolutely happen on when you're doing repairs, and it's something to watch out for. And the way you found it is fantastic, and we're going to talk about that some more here later.
And a couple of things coming in the chat, Robert, about thermostats and people cheating thermostats. One that I haven't even seen, which was taping over the temperature display on the thermostat, which blocked off the airflow through the thermostat, so it couldn't sense the temperature of the room as easily. So
Yep.
that's interesting. In other words, hanging a bag of snow over it.
I've
Sounds like
not
those
seen
have
snow,
dummy
but I
thermostats.
definitely have seen damp paper towels hung over them before. That was kind of the go-to in the schools where I grew up, to get the heat to kick on for the old pneumatic stats.
Yeah. And the occupancy sensor, doing stuff with the occupancy sensors to cheat that. Definitely something I've seen happen.
Yep.
Even to the point of people just damaging them so that they don't operate quite right,
Yeah.
which is an issue.
Hey, Gene, would you mind speaking up and sharing a little bit about the one that you put in the chat, please? I'm curious.
Yeah, so we have about our 5 schools that have the same plan. It has a full mezzanine above the classroom extension of the school. There's about 3 extensions at a particular school. Anyway, I was walking this one. I like to walk it especially during the cooling season, and just make sure that the pans are dry, and make sure things are all right. But I came across this one unit. It was one of 2 units for the gymnasium, so it was a pretty sizable unit that didn't seem like anyone was working on it, but the disconnect was off. So I turned the I engaged the disconnect and looked at the system on the automation, and I didn't notice anything strange, but I just kept walking. However, the next day, something must have happened where the unit began smoking, and there was a big call from the county emergency system. I mean, to the county emergency systems, couple of fire departments out there, and the county sheriff and things like that. And apparently, it was because of that unit that I engaged, heated up somehow, and caused problems. And that's my first experience with lockout tagout situations that should have been.
Absolutely. Great call out to lockout tag out there. And that's also a great opportunity. We've had several people mention it in the past or in the chat already today, and it'll come up again before the end of the presentation, I guarantee it, of documenting why things get overridden. Whether you've got a notebook sitting by the computer or a shared online document, whatever your methodology is, making sure people use that. And yeah, sometimes that doesn't really work when you have one person that's doing everything and it's all in their head, so they don't think they've got to write it down or don't want to write it down for job security reasons. And then one day they're gone by their choice, by someone or by someone else's, or by the wheels of a bus. And the new person comes in and finds all of this stuff that's been, shall we say, adjusted, and no idea why any of those adjustments were made. So documentation.
And that's one of the things I think you're going to see more and more of in the future is those documentation requirements, because it's such a critical part so that we don't lose what do you call it, the building history when whoever it is retires.
What
I ran
Peter
into a
called tribal knowledge.
tribal
last
knowledge.
week.
Yeah.
Yep.
It needs to be paper knowledge or electron knowledge and electronic copies, right? I ran into a building. I was doing an energy audit back in early aughts. I walked into their boiler room and they had two pumps in a system running, which is lead leg system. And I asked the guy, I said, well, why do you have both pumps running? It was heating season. And he said, well, that's the way it was when I started here. Joel did it that way, so I'm doing it that way. Well, how long did you start here? Well, about 5 or 6 years ago. No documentation telling him why. In that case, I said, well, this is a lead leg system. You have two pumps running. You're possibly screwing up your controls because you might be putting too much pressure on the system, overheating areas because valves are being forced open, and you need to test running just one pump. So not to do it that particular day because it was below zero outside, but do it on a day that he has a lot of time to put effort into watching and seeing what's happening so that he doesn't run into a problem that was a reason why the system was set up or changed that way. So
Yeah, it reminds me of there's a story that I've heard a couple of times, that's right along this conversational length. Couple been married for a couple of years. They decide to have a ham for Thanksgiving that year. And when the person who's cooking goes to put the ham in the oven, first thing they do is they cut off the end of the ham. Cut off about 3 inches of it before they start cooking it. And their spouse, having never seen this before, asks, why do you do that? And the cook says, I don't know. It was how my parent did it. And the non-cooking spouse is like, oh, okay. But starts to think about it a little bit and is like, hey, can we call your parent and say, hey, find out why they did it? I'm just really curious what the reasoning is. And they call the parent, and parent says, oh yeah, I've always done it that way. But why? Well, that's how your grandparent did it. And they're like, okay, well, that's not the root of the cause, but we're getting there. Let's call the grandparent. And they call up the grandparent. And the grandparent says, yeah, I always did it that way because our oven was too small to cook the whole thing. So we're still continuing wasting that portion of the ham 3 generations in and 3 different stoves. And that's why we're still doing it, even though we probably have a stove perfectly capable of cooking the whole thing now.
So I'm curious as to what type of mechanisms people have seen for outside air dampers being pried open or closed. I've seen a number of different methods and some still boggle me as to the effort that people put in to do this when they could have just corrected the system properly. Anybody have some thoughts?
Antonio says duct
Duct tape.
tape.
All right.
Holding it open or holding it closed, Antonio? Closed.
2x4.
That makes sense.
I've seen a 2x4.
Yeah.
I think the most creative one I've seen is somebody took a 2x4 lay-in ceiling tile, cut a 2-foot slot into it, put it over the damper blade to keep that damper open for exhausting the building. That was a creative one. Phillips note HRV plug.
Wow, that's an impressive quantity of work there. I've not seen one like that before.
Yeah. Toilet paper rolls.
Now, that's not to say I haven't seen pillows in air handlers before, but it was not for outside air damper purposes. It was recreational based, we'll say, or task avoidance based in some cases.
Oh, Aaron says plastic over the intake grill.
That's an interesting one.
I've seen a similar take on that where somebody took and cut plywood and drilled it onto the outside. These are unit ventilators on the outside of a school building and closed up their outside air intakes with plywood. Saves energy, right?
It absolutely would.
Of course, it does a lot of other damage.
Potentially. Those are some good ones. Definitely some that I haven't seen before. I don't have any particularly exciting ones.
Not my problem. I didn't document all the ones I've seen over the years. Should have.
If only digital cameras were around when we first started, right, Ted?
Yeah. I was telling Robert last night that the 2 pictures on his slide are actually from about 2000 or so, and the cameras weren't very good back then. And I had quite a few pictures from that period, and a lot of them show up like this one on the left where the air handler was kind of fuzzy, not good clarity.
Adam's got a good one that I've definitely seen before. People using the unit ventilators as shelves, covering the supply air. Yep. Or blocking return air with, furniture in the building as well.
It's a great place for a shelving unit or a file cabinet. Opening windows. I think that's the bane of every building operator's existence, right?
It's either opening windows or plug in heaters.
So when we travel across our district, we typically stay in the school, especially if there's large group events. All the kids, they camp out in the gym or something, and occupancy sensors are it's kind of standard procedure to get some black tape and cover it up so the light's not going off every time somebody moves. And sometimes they're forgotten about, and everybody's running around trying to figure out why the lights aren't coming on. And then another school in particular, we have set up like extra mattresses to. I'm a little bit taller than everybody, and I figured it out. My feet were kind of past the barrier, and I was wondering why everybody was always sleeping behind this mattress, and I found out because the light kept on clicking on because my feet were a little bit past the barrier there. Yeah, it was pretty funny.
Interesting uses.
Yeah, Larry hits on one where Larry Morris. All evidence of having people in a position without training and knowledge. And we're lacking the training, we're lacking continuous upkeep of what we know. And I don't care if you're experienced or not, you continually need to keep yourself updated in order to keep on top of technology. And that's what like this training's for, try to improve what we know so we can do a better job when we get back to work.
Yep. And that's that knowledge of how the systems are supposed to work was why we had that longer section on design intent and sequence of operation, because it is so critically important to understand how the system is supposed to work or how it was intended to work at design. Maybe the circumstances have changed and the sequence needs to be changed accordingly. But if you don't know how it was supposed to work, it makes it really challenging to run it effectively, let alone efficiently.
All right, we should probably move on to the next slide.
Yep, some great points, and don't worry, we've got some more coming for you. So, what about overrides inside the BAS? What have you seen that's been overridden? We've talked about a couple of things already in your examples that you found in your buildings, but let's share some more kind of general types of things that you've seen less than specific instances. What do you have? Emergency override. Adam, you want to give us tell us a little bit about emergency override? And it blew up a heat pump. That's exciting.
No, the override was so the system didn't activate because the heat pump caught on fire.
Oh, gotcha.
Yep. So one is typically reserved the priority, I believe, for emergency services or whatever. So I feel like that's something I should mention in here too.
We'll get to that here in a minute. Don't worry.
Yeah, that's what I didn't want to bring it up yet, but that was another example I had, but I'm running empty here.
Fair enough. Hey, no, it's a good one to have brought up. And
so I actually wasn't in facilities. I was in IT at that point. The only reason I know about it is because I was the person everyone came to for everything.
Gotcha.
Yeah.
So there definitely can be different priorities of overrides depending on what your system manufacturer tends to like to do. Emergency overrides are generally right up there at the top of our list. We'll talk more about that here in a second. Let's see, Adam says, I'll still have a lot of slide stats, so override all the adjustments so the teachers have no control. Yep, good old placebo thermostats, right? We have an input into our system, our set point adjustment. We override it to lock it into a specific set point so that it doesn't mess with things. Very normal thing to do, but it still gives the people that feeling of control because they can move the slider. Does a lot for them.
Now, I'm a little conflicted on that one. I like to give them some control over a little bit of adjustment. So maybe just a matter of only give them a 1 or 2 degree variability, not 4 or 5. It does provide them a little bit of comfort, but the placebo effect does that too, I guess.
It can. It depends on the person. Yeah. And I have seen it work both ways, where it's can be a double-edged sword, where sometimes it works and sometimes it causes you more problems.
Yeah.
But it is a tool when they have too much adjustment, because I don't know about anybody else. I have definitely seen a lot of lay folks walk up to a thermostat and, you know, it's turned up and they turn it all the way to the bottom. Doesn't matter to them where the bottom is. Could be 68 degrees, could be 50 degrees, but they crank it all the way down. And the next time when they're cold, they crank it all the way up.
And what they
I've
don't
seen
realize,
some that don't do that, but I've seen more that do.
what they don't realize is it's not going to get to a comfortable temperature any faster, whether they change it 2 degrees or 1,000 degrees. It's still going to take the same amount of time.
Absolutely. Looks like Antonio has some good examples: occupancy mode, set points, commands, and VFD speeds. All great examples of things that you can override in your building automation system.
Kind of our list almost, isn't it?
Boy, man, it's pretty close. So
So
those are
Adam,
some
it allow it 68 to 72 degrees. That's not too bad.
Yeah.
That's a good range, I think.
pretty good comfort zones.
So what's Fred Flintstone's stat mean? Adam?
Caveman technique. They're gonna hammer at it, rip it off the wall, blame me for it. No, so actually, this is probably not related, and I was just typing it out, but it might be easier to say it. So I was doing an energy audit at our high school, and we recently had contractors replace a lot of the systems there, and they failed to centralize the controls when they said they would. So the user still had local controls over the stats. So when I was doing the energy audit, I started getting sick because they set it to 86 degrees. So the office felt like summertime, and just the amount of air and how thick it was. So it's definitely probably not the best idea to let people have complete control of their zone, but I think giving them a little bit, helps them be a little more comfortable, and it's reasonable. I'm not giving them the opportunity to, burn the house down or anything.
Well, Aaron is saying that he had 1,500 overrides on his system at the start of the year. That's quite a few.
That is that's a little bit extreme. I mean, I've seen some systems that were that bad or worse, but yeah, that's pretty not fun. And just clearing them all out in one go. That's a way to restart at the
I mean,
beginning.
if you're overriding so much, eventually you're going to defeat the purpose of the automation system.
Yeah, nothing's
Absolutely
automated,
true.
right?
Yeah. If it's all manual.
Well, and yeah, I came across a situation at my school where they had so many overrides in the system that they gave up trying to deal with them. So they hired one of my students who graduated part-time, and he spent 4 months knocking out the overrides, figuring it out and addressing them all.
We've got some really great examples there. But let's go ahead and move on just a little bit. It's still on the same topic, but next slide, please, Ted. So within our BAS, as you've already come to the conclusion, we can definitely override schedules. We had specific examples of that and generalities. Outputs, directly overriding a valve or a damper or the speed of a VFD, or even just it turning it off. Set points, sometimes we override the set points. Sometimes there's good reasons for it. Sometimes there's not so good reasons for it. I worked with a person for a number of years who their go-to move was to, anytime they had a hot or cold complaint in a classroom, this was a school, that they would go to the air handler that supplied that area, and they would override either the hot water or chilled water valve at the air handler. It was one of those situations, as the saying, don't use a cannon to kill a mosquito. But this person, that absolutely their go-to move. At the end of their shift, that was one of the things I was assigned to do, was to go through the activity log and find what they had done and undo it. Just one of those things. But the short answer really is anything that we can write a value to. If we can right click on it or left click on it, and it pops up a window that lets us type in a value, maybe has a checkbox for override or manual or something like that. If it has that capability, we can override it. Is it always appropriate to do so? Not necessarily. And don't get me wrong, I'm not going to sit here and tell you that I think overrides are bad. I don't think overrides are. Overrides are a tool in our toolbox. Sometimes shutting off the disconnect for a unit that is hazardous, or shutting off the disconnect while you work inside the unit. Again, lockout, tagout. That is a tool in our toolbox. Documentation really helps with that. And again, something like lockout, tagout to prevent hazardous situations. But for the most part, or almost exclusively, overrides should be treated as a Band-Aid, as a temporary, let me reiterate that, a temporary fix. You all know it. So many of you are dealing with overrides that have been in place for you don't know how long, you don't know why they were there, but they've turned from what was probably intended to be a temporary fix to a permanent fix. That's when overrides become a negative instead of a positive tool. And just like any other tool in our tool belt, just like the hammer, just like the screwdriver, there are appropriate uses for them and there are inappropriate uses for them. You aren't supposed to use a screwdriver as a pry bar. Do we do so? Yeah, we definitely do. And sometimes we end up paying the consequences. Consequences of a broken screwdriver or a broken piece of equipment that the screwdriver broke because it wasn't the right tool, or a broken finger because the screwdriver slipped and, well, our hand was the casualty. Those kind of things happen. It's all about the appropriate use of that tool. Next slide, please, Ted. Now we're going to start to get into that part of the conversation. Is there anything we shouldn't override that we might be able to, but we shouldn't? Please note all caps there. Anybody have any ideas of an example of what that might be? Is there anything we shouldn't?
I don't know if it's possible, but CO2 sensor?
So I'm going to back that up as a category to inputs.
Okay, so don't override input. That sounds good. Yeah, don't do that. Yep.
Don't override inputs. There are some systems out there that will allow you to override inputs.
I would say maybe if you touched ATC stuff, maybe at least inform the authorities. Like, I don't know if your all systems tie into your alarm controls and what.
Yep.
But let either your security, whoever's in charge of that, know before you do it, or just don't even touch.
Yep.
Yeah, like Damien says, fire alarm. You don't want to override any fire alarm settings.
You might not be able to based on code. Like,
yeah.
I remember when I was a hotel manager, I was not supposed to acknowledge things without a fire marshal on site.
Yeah. But there is a significant difference between not supposed to and not able to. And that's something that we do have to keep in mind. But yeah, absolutely. Fire alarm systems. If personally, I am not qualified. I have never been trained in fire alarm systems. I've been asked to work on fire alarm systems in the past, and my flat guarantee is, or statement is, no, I am not trained in that. I am not safe to work on that. I'm not touching that. But there are inputs into our HVAC systems from fire alarm. Many of our air handlers, rooftop units, larger heat pumps and fan coil units, things like that, many of those have fire alarm tie-ins because they're supposed to shut down during a fire or smoke situation. Or they may be exhaust fans that need to turn on specifically or reverse direction and go from exhaust to fresh air for something like a stair tower. Overriding those systems, don't do it. Don't do it.
Generally, anything as a safety.
Anything that's safety, and that falls into that category of life safety equipment, which is, I believe, where Adam was headed earlier. with those emergency overrides. Emergency overrides will not override life safety priority. That is priority number one. But that doesn't mean that it was exactly set up right in the control system, and you may be able to override things. Again, you shouldn't. So we have had a couple of other suggestions of items. Pumps. Depends on the situation. If it's a fire sprinkler pump, you better believe I'm not going to override it. Again, life safety systems. But if it's a hot water pump or a chilled water pump, something like that, there may be a valid circumstance where you need to override it. Shut it off so that you can work on it, so that you can do your preventive maintenance, do alignments, filter changes, or strainer cleaning, stuff like that. Valid reasons to override it. Generally speaking, though, it falls into that category again of let's make it a temporary fix so that we're using our override properly. And the same can be said for exhaust fans or roof fans. Again, as long as they're not part of the life safety system. Now, I'm not telling you that the life safety system doesn't have maintenance, that it doesn't need maintenance, because that's a lie. It absolutely does need maintenance, especially the mechanical parts of it, like exhaust fans. But those systems should have special procedures associated with them for when it is okay to do that maintenance. It may be during an unoccupied time for the building, especially for something like a school. And there may be special circumstances that you have to guarantee while you're doing that maintenance. You know, you have to make sure that you're only doing the maintenance on one of two things that do the same job. You can't do the maintenance on them both at the same time, something like that. Anything else that we should not override? Cool. We hit the ones that I really absolutely needed to talk about. So anybody have any questions on that? All right. Well, if you think of any, put them in the chat, raise your hand. You know we'll do our best. Next slide, please, Ted. The challenging part, or one of the challenging parts, finding overrides. Next slide, Ted. All right. How do we find overrides? I like to put it into three categories of tools. We'll talk about each of them individually, but before we get to it, anybody have any guesses what those types of tools or categories of tools might be?
We've talked about at least two of them today already.
We
Some people
absolutely
brought
have.
them up.
Override reports directly from the BAS. That falls into one of those categories, yes. Those reports are amazingly useful when you're not completely overwhelmed by them, at least. BAS panel point log report, yes. That falls into the same category as our override reports, yes. Global search options. Gene, I'm guessing you mean within the BAS? And yes, again, same category, but absolutely.
Physical displays on equipments or looking at them?
Sometimes you can, yes. You can look at the graphics built into your BAS. That would be another in the BAS category. The displays on a local piece of equipment, they may show you some things too, though in some cases they may not. Depends on how it's set up. But something like a variable frequency drive, often you'll be able to see that they're in hand. Ribs, I'm guessing you mean relay in a box there, Adam? Yeah, they've got, some of those have handoff auto switches. Yep. Let's go ahead and jump to the next slide, Ted.
Okay.
We'll get into the categories. Because we did focus real heavy in one category, but we missed the other one that we had already talked about. The stories of our buildings. You know, every building has its story, right? Every operator within a building has countless stories about that building. You know, specific issues they ran into, how they solved those issues. And we've talked multiple times about logs, writing down and documenting your overrides. Those are part of the story as well. Hopefully, if they exist. But yeah, the stories. Listen to the people in your buildings. Listen to the occupants in your buildings. They may be able to clue you in on stuff that you wouldn't necessarily notice, especially if your job is to take care of multiple buildings or multiple areas in a big building. Okay, so that's stories. I know it's kind of a weird sounding category for this very technical topic we're talking about, but listen to people. I can't count the number of times that I was called in to solve a problem and I sat down with a building operator and they told me, one, exactly what the problem was when I only had a vague answer before, and two, exactly what I needed to do to solve the problem for them. They just didn't have the knowledge or the tools to be able to do it, or weren't authorized to do it by some administrator or rule. So those stories, they're powerful, man. Next slide, Ted. Oh, Damien.
Yeah, I just want to say stories are sometimes misleading also.
They can be.
Yeah, I do some electrical work here and there, and one of my mentors said always start at the source of power. I've been led down some rabbit holes by people sometimes where I'm just taking things apart that had nothing to do with anything. If I would have just went back and looked at voltage, it would have, I would have fixed the problem. But yeah, sometimes stories are misleading for me.
Absolutely true, and something to be cautious with. If the story doesn't make sense, take it with a grain of salt. Listen respectfully. You still might be able to gain useful knowledge. But especially if somebody's just trying to tell you, oh, the problem is over here. Okay, you're trying to tell me the cause of the problem. What's the actual problem? Was it a hot call or a cold call? Was it a squeaky noise from the roof? What is our real problem here? And start there. You're absolutely right, Damien.
I think something else that Damien commented on there was he went back to the source of where the power is coming from. And I find in controls that often you need to go back to the source of whatever control power you have or control signal you have in order to track down where the problem really is. So, because you got to verify you got that source supplying your end issue with energy to make changes. And so that's actually a really good troubleshooting technique that he just mentioned.
Absolutely true.
Yeah,
Adam likes the statement, trust but verify.
Yeah, sorry, that's just one statement. Is always start at the source of power. It's worked so many times, especially if it's late at night and your brain's foggy and you just don't even know what to do. Just always start at the source of power.
Yeah, that's a really good one, Damien.
Yep. And don't assume that somebody before you already thought of it.
Got in trouble doing that, making that assumption.
I have as well.
Yeah, I've gotten in trouble a lot. And it took me a while to figure that out.
It's how we learn. Or one of the ways. Next slide.
Let's go ahead and go on to our next slide. I think it is our category that No, it's not the one that I was thinking was next, but that's okay. Abnormalities. What do I mean by that? Complaints. If it's a hot call or a cold call from somebody who isn't calling in on a regular basis complaining about something, that's an abnormality, right? Or conversely, if you're always hearing from one person that it's too hot, it's too hot, it's too hot, but you know they're there that day and they're not complaining that it's too hot, that's actually an abnormality too. Alarms from your control system or alarms from outside your control system. Definitely signs that there's a problem, right? Well, those can be caused by overrides just as effectively as they can be by natural mechanical failures. Okay. And trust your gut, especially if you know the building you're in. If you're surfing around on the graphics, like for an air handler or something, and you see something that just doesn't make sense, you know, I've got it phrased down there, that doesn't seem right. For one, trust your gut. Go and look at it. If it doesn't seem right, the system could be lying to you. Or something could be broken or overridden. Great example. If you see an outside air damper that's 100% open, if you see a mixed air temperature that's 45 or 50 degrees out or coming into the air handler, your hot water valve is 100% open and your discharge air is 48, does that seem right to you? No temperature rise off your hot water coil with a valve that's open 100%. Shouldn't seem right. Something's going on. Maybe that valve is overridden or broken. Maybe we've got a hand valve, a ball valve, a shutoff valve that's been closed and is preventing that coil from warming up. Or maybe our problem is actually back at the hot water system and we've got all our pumps are shut off or our boiler's shut off and it shouldn't be. Things along those lines. Again, Troy in with the valves or actuators disconnected from valves or flipped on rotation. Yeah, those are exactly those kind of problems that show up as abnormalities. You know, our chilled water valve is completely closed, but we're getting a 12-degree drop in temperature across that coil. Is that valve closed? I don't think so. Not unless you have figured out a way around the laws of thermodynamics, which if you have, please call me. I'm very interested. Okay.
You won't be able to call them because if you've gotten around the law of thermodynamics, we're in a lot of problems.
Yeah. Yeah, you've stepped outside of our known universe at that point. Not good cell reception there. You're right, Ted. Antonio says a good BAS operator can actually anticipate what should happen on graphics when variables are changing. Yes. If you've taken a little bit of time to watch and understand how your system works, you make a change on a set point, you should, like Antonio says, be able to get an idea about what should at least start changing. You may not know its final destination of where it's going to lock in at, but you know, you turn up your discharge air temperature set point, you're going to expect something like your outside air damper to close a little bit if you're in economizer, or your hot water valve should start opening a little bit, or your chilled water valve closing a little bit, something along those lines. Absolutely. Trust in what you know, but be willing to admit that you don't know everything. But pay attention to things that just come at you out of the blue and don't seem right. Most of the time you'll be right that something's wrong with it. Next slide, Ted. And this is the category of tool that we got the most comments on. Our graphics, our alarms, our reports. Some systems call them list views, where you can pop up an active list of what points are overridden. Maybe on a graphic, they show up as a different color. I know the Niagara systems by default like to use kind of a light purpley lavender type color. Anytime you see a point that's that color, you know it's been overridden. I think Schneider uses the same concept. Johnson uses the same concept. They just use slightly different colors. Some of the other systems, they may not show up as a color. Sometimes they may show up in a flashing state. There are lots of different ways that they may be affected or showing. Whether you see them in graphics, maybe you see them in the tree, the navigation tree along the left-hand side, and see that it has some sort of an exclamation point by it, or some sort of little symbol there. I know in the old Andover Continuum system, they called them bangs on the points. Sometimes they meant different things depending on what color the little dot was. Lots of systems have them. Lots of systems have the ability to run reports on your overridden points. Running those on a regular basis so that you can see those items that you put a Band-Aid on and were so rushed that you forgot to document it. Running those reports on like a weekly basis or a daily basis or a monthly basis, whatever your scheduling allows, can bring those items back in onto your plate so that you don't forget about them and your temporary override doesn't become a permanent fix. Okay. And if you don't know how to use those tools or use those things within your building automation system, that's a really great question the next time you're with one of your more senior technicians that does know how to do it, or with your service provider the next time they're in. Okay, whether they're fixing something or it's a maintenance call or whatever. Ted, anything to add on those ones?
No, I other than when I've been on a system, I quite often use the list view. It's just what I'm familiar with, so I do it.
Yeah. Anybody got any questions on any of those of how to find an override? All right. Next slide is yours, Tim.
So why do overrides happen? I think we've been talking about that all day already. The main thing that I've seen are short-term fixes. You get a complaint, you go out. In order to address that complaint, you do an override on temperature set point or close off an outside air damper, whatever it happens to be. And then you forget about it because you get pulled on to the next emergency, and whatever you did stays in place for who knows how long. So what have other people experienced? You know, what are some of the main reasons that you use overrides? Why do they happen? Let's see, I'll go in here, I'll see if there's some people who haven't had a lot to say here today yet. I haven't heard William Toro. Have you come across anything? And do you like to call it William or is it Bill? I'll let you think about it and I'll come back to you. How about Nina? make sure you're on mute. Kaylee, we haven't heard you today. We heard you last week. Anybody else can go ahead and jump on in.
Jessica has one in our chat. They have a
Okay.
building that just doesn't want to heat up, so its CP is overridden to 25% at all times. Sometimes it gets too hot, but rarely too cold. What do you mean by CP there, Jessica?
That's what I was wondering.
The circulating pump from the boiler into the heating loop for that system. It just, probably the whole loop needs to be flushed. There's probably some clogs somewhere, but I don't know enough about it to say that with any certainty. But once it gets cold, it just is really hard to reheat. It's the oldest wing of the high school, and there's like been a lot of add-ons. So the boilers are fairly new. There's definitely not a problem with producing enough heat. It's getting it to circulate down there. So instead of allowing that, if I take the override off, that circulating pump will fall right down to 0 and it won't push any water. I don't quite understand why. And I hope when I get to the bottom of it, I can get back to having that running off differential pressure to change the circulating pump speed. But for now, it's got to be a minimum. It's got to be at least 25% or it gets cold. And here in Alaska, it's better to be warm than cold. So especially at this time of year and all winter, all school year. Once it's summer, it's not such a big deal, but yeah.
That's an interesting one. What kind of heat or devices are using that hot water? Radiators, radiant heat, something like that?
There's an air handler for that unit. So we pump the heat down to the air handler, and then each room has a VAV that can receive. And then there's also like a baseboard, a baseboard loop that goes along the windows.
Mhm.
And this particular building is shaped like a donut. So it has an interior courtyard with windows, and there's the water runs through that interior loop along the windows, and then then there's a hallway that makes a donut as well. So you have classrooms on the inside and classrooms on the outside. And then there's the exterior loop, and there's 2 big entryways that, have really, really badly sealed doors. So we get cold air that's let in through there. And then when the remodel happened, part of that section got attached to the new HVAC system. So it's just very difficult to control the heat in that segment. And I didn't understand until earlier today how the differential pressure should affect that pump speed. So I'm grateful to have learned that little bit of knowledge that makes a difference for me.
Fantastic. I'm gonna posit here. I've got an idea of what may have happened in this, and it's one of those stories that definitely happens when we're doing remodels of systems, is that maybe something was controlled via pneumatics previously, and when it may have gotten missed on the upgrade, or it may have been something that was set up on a previous system with like a minimum speed for that pump when the outside air temperature is below a certain point, for example. And that just didn't get transferred over to the new system or the new variable frequency drive. And I am 100% guessing here, so I could be absolutely wrong, and I will tell you that right now. But I really wonder if those radiators along the outside and inside of that donut under the windows, if those don't actually have any control to them, and they're relying on that circulating pump and the hot water temperature to be the controlling factor.
Yes, I believe that's the case. I don't think the individual thermostats have any effect on those baseboard. And that's partly why it's difficult to control. Classrooms that are closest to the circulating pump tend to be warm, comfortably warm all the time. The ones furthest away are the ones where the VAVs are turning on much more frequently to maintain temperature. So But then if we have a sunny day and the sun is just beating down, then it heats up and all of a sudden I'm getting it's too hot, it's too hot, it's too hot complaints, where it's really hard to then it's actually pretty hard to cool that building down too if it does get too hot, which isn't often. So
Believe that. That one of the tools I would suggest looking at consulting to help solve that problem would actually be a balancer. Because it sounds like you have some complex flow situations as well there that may benefit from a little bit of attention from someone like that.
Thank you.
But definitely a great example of why overrides happen. Let's see. Ooh, Antonio, I like your first one. Operator error. You meant to do something one way and you didn't. Just hit the wrong thing. It happens to all of us. Non-functioning equipment to bypass it, like we've discussed several times. Temporary fixes. Nothing wrong with a temporary fix, right? Forget to reset it. How temporary fixes become permanent, right? Equipment not functioning correctly. Outside air dampers not working properly. Override return dampers on the air handler to compensate. Yeah. A lot of these are falling into what should be short-term fixes, right?
Yeah, that's what I was noticing also. And that's a great place to use overrides.
Absolutely.
Short-term fix, you put an override until you can get to it to take care of it.
Yep.
But that getting to it to take care of it is always a sticky point.
Really is. And I do want to point at Antonio's comment just a little bit more there for operator error. And Antonio chimes in, the override should not be the fix. You are absolutely correct. And we'll talk more about that here in a minute. But operator error could also fall into the category of the operator being misinformed or underinformed about how the system's supposed to work. You know, we all have limits to our knowledge. If we go into a situation and we think it works one way, but it really doesn't, we may put in an override trying to make it work the way we think it should, and that could be wrong. Could lead to a permanent override because, well, we can't solve the problem because there isn't a problem to solve. Or just a general lack of knowledge of the person. We've all worked with people who don't want to deal with the control system and do everything they can to bypass it. Do you have anything more on that one, Ted? I'm sorry, I took over.
No, that's okay. I don't. So we should be moving on here. Let's go on to the next one, which is preventing and resolving overrides. And
those posts look terrible.
What's that?
I think Aaron accidentally hit his unmute button.
Oh, okay. Well, slide doesn't look that bad. No, just kidding. So you want to go ahead, Robert?
Oh no, this one's yours actually. I thought.
No, this one was yours.
Okay, I'll take it. Not a problem. So, how do we prevent the need for overrides? Okay. Testing our system. Make sure that it works. So, oftentimes in a modern construction process, we're going to commission our buildings. Okay. And that means that we're going to go through and we're going to survey a certain number of the points to kind of guess that the building has been fully checked out. You know, we've got 100 hot water valves. We're going to look at 10 of them and make sure they're doing what they're supposed to do. That's in the construction side. But ongoing commissioning is something that falls more on the operator's responsibility. So for those, we have the opportunity to look at everything. And you don't have to look at it all in one day, don't have to look at it all in 1 week, but go through and check stuff out as you work on it. You know, if you have to replace a fan belt on the air handler, take a couple of minutes, check to make sure the VFD's in auto, ramp it up and ramp it down, make sure it's responding to your control signals. Okay, check it out and document what you've tested so that, you know, you test it this week, Frank doesn't come along and test it again next week. We want Frank to go test something else. Okay.
Yeah, and Robert, what you're describing there is, you know, part of a really accelerated maintenance program where you integrate ongoing commissioning into your maintenance process, documenting it as you go along. And not, I don't know, just a quick question of everybody, how many people have a computerized maintenance management system?
Like to put tickets in and stuff like that?
Yes.
Yeah, we have Asset Essentials, School Dude.
Okay.
Who else in the chat?
Use that.
Or speak up.
Kaylee says Anchorage does.
Yeah.
Facilitron works, yeah. Zendesk.
Yep.
Boy, some names I haven't heard of before.
Yeah, same here. School Dude. That sounds like a fun one.
It's Asset Essentials. They changed their name. Yep.
I've heard of them for years.
I honestly thought the name was very stupid when I heard School Dude. It doesn't reflect what the product does at all, but
FlowPath. Yep. There are a lot of them out there. They can be amazingly helpful when they're well set up. When you can get it all plugged in for your preventive maintenance schedule.
you might be able to see why the override was put in place.
You might be able to see why the override was put in place. You may
Assuming people document their work.
Assuming it's used. And that's absolutely the case. It has to be set up properly to begin with, and it has to get used as you go along. When you get a work ticket, you need to record what was done. You know, it can really help with showing you patterns for failures.
You also have to train your customers or users how to put the tickets in and to actually put more than, I'm going to say, of course, computer slow. Doesn't work.
Yeah.
Yeah. Detail is important.
Yeah, and it's part of that too. Trending can be a really important tool. So maybe integrating trending of systems into your maintenance process so that you take this air handling system this week or month, trend it, and have an ongoing process to set up trends.
It can also be helpful if you have like a lemon product. Like we had one line of laptops that had a defective port in it, and we were able just to pull all the tickets and send it to Dell, and they couldn't even dispute it. They completely replaced the whole fleet of laptops instantly. Because we had such good documentation on these ports failing in the field.
And that's exactly that same kind of thing can happen with actuators, compressors on things like heat pumps or rooftop units. Documentation wins the battle.
But it's always so hard to do. That's the issue, right?
It's most of the time it's easy to do the documentation. It's hard to find the time to do the documentation. Right? We're all busy. We understand that. Another thing you can do. Oh, go ahead, Ted.
That's back to a comment I made in the chat earlier that time has to be allotted. The higher ups have to provide time to accomplish some of these things.
Yep.
So
And if you're a supervisor, if I may suggest, the job isn't done until the documentation is done. So if you have to, charge out time to specific service tickets or things like that, make sure that that documentation time is also something that lands in that pot. It will help you or make sure that that task gets completed. At least that's been my experience. Another thing we can do to help decrease our need for overrides is to increase our knowledge of our systems. Go find those sequences of operations. Find the as-built drawings. Go listen to Carl talk about how this system is supposed to work. Carl, in this example, being the person who's been around, understands this particular boiler, how it works, how it likes to work. Really useful. And of course, back to that issue we were just talking about, time. Make sure that you have time to address properly your issues. Again, moving on from it being just a Band-Aid fix. Yep, you got to Band-Aid it because maybe you don't have the part to fix it, you don't have the time to fix it, you don't have access to fix it. That's fine. That's what overrides are for. But the next day, when you do have the part or the access or the time, go in and put in the permanent fix. Okay.
Did we mention alarms for preventing overrides? Like setting alarms in your BAS and reporting them, having them send emails or whatever text to stakeholders or technicians?
No, but that's a great one, Adam. If you can set up your BAS, and many can, to send out a report for overridden points, you can have it addressed to the people who did those specific overrides or to a supervisor to make sure that those overrides are, again, temporary. Next slide, Ted. Okay. Going through the process. Oh, go ahead, Ted.
I was going to say that first bullet point or number there is determine why it was needed. It's really critical. So go ahead.
So resolving overrides. Okay, we found our override. We know it happened. Okay, let's figure out how to get it past that temporary fix and move on to a permanent fix. Step one is determine why the override happened. For the example of the fan coil unit that was shut off at the disconnect, no documentation, no lockout tagout. Well, turn it back on. Next day, we get the fire department. We needed to find out why it was turned off. Okay, not putting any shame on it. There probably was no documentation, no idea why it was off. There should have been. But if you're the one who overrode it, check your notes. I don't know about you, but my memory is terrible. So I take notes when I do things like that so that I can go back, and when I see it turned off, I can go, oh, why was that turned off? I get out my little notebook and I check. Yes, I'm still that kind of person. I carry a physical notebook. Anyway, if you're not the one who overrode it, check the logbook, okay, or the shared document. Why is the override on air handler 3? Why is this VFD in hand at 30%? Okay. Ask your coworkers, hey, air handler 12 is off. Anybody know why? What's going on with that? Is somebody changing the filters, belts, greasing bearings, or has it fallen off the roof and nobody noticed? Okay. Good chance that somebody has noticed the issue or may be the source of the override. Last option, release the override and see what happens. You got to babysit it a little bit just to make sure, though. Okay. Now, let's say we know why the override happened. We had a hot complaint in the third grade reading room. Okay, override was put in place. Maybe it was a physical override. We shut off the ball valve for that zone control because the real reason was the actuator was dead. We had to get a new actuator in. We didn't have one in stock. When it shows up, we go put on the actuator. We release the override, right? Simple. Find the underlying cause that required that override as the fix, as the temporary fix. Hey, look at it. It says documentation. Again, it's like that's important or something, right? Document what was done. Okay. Maybe you find an override that you have no idea why it was there. You start doing your research, you find out that it was a broken valve or a belt that fell off and never got addressed, something like that. Maybe your fix that you ended up doing to resolve the underlying issue is actually not that much harder than clicking an override into place, whether in the real world or the computer. Doesn't matter. If your fix is almost as easy or easier in some cases, maybe that's a better fix than using the override in the first place. Okay? Or maybe your documentation is going to show you that, oh, we had this failure, these belts broke because they hadn't been changed in 5 years. Okay, maybe that's our cause is a lack of preventive maintenance. Or maybe we need to grease this bearing every 1 month instead of every 2. We just had too much friction in the system and burned up the belts. Those kind of things happen. You know, adjusting your preventive maintenance or adding an item to your preventive maintenance is a great way to help avoid the need for overrides. Okay. Maybe keeping a spare actuator in stock is that solution. You've got it in hand. If it's going to be that easy to go and just grab it off the shelf, throw the new actuator on, change 3 wire nuts, and you're done. That's not much harder than an override, right? Again, keeping those fixes temporary. Okay. And is it always practical? No. Is it always possible? No. But where it is, it'll make your life a lot easier. Last up, monitor the system. Make sure that what you did to fix the problem actually fixed that problem, for one, and 2, didn't cause another problem. Because sometimes that happens, right? You fix one problem, maybe a disconnected linkage on an outside air damper. Test the damper, everything works, fire it up. During the daytime, it runs great. And that night, we trip a low limit thermostat. We caused another problem. Before, our outside air damper wasn't opening, so we didn't get too cold. Now we got too cold. Time to go back and reevaluate and find what's the source of our new problem. Okay. Properly resolving overrides, properly fixing physical problems in your system, amazingly useful. Does that make sense to everybody? I mean, it makes sense to me. I'm the one who wrote the slide, but by the way, I think I'm funny. If you don't think I'm funny, that's okay. I'm not bothered. Thank you, Jessica. Thank you, Carlos. All right. Next slide, Ted.
I have a question for you first, Robert.
Fire away, Ted.
Are we going to be, are you going to be able to go on and show on your computer Bob tested it?
I can, but honestly, we're running kind of low on time. And I think what I'd rather do is just drop right into that next week.
Okay, I just want to clarify that.
Great question.
All right. So it gets us into the last area for the day then. And that's, what is the impact of overrides? Well, one of the big areas is energy. And as a general statement, overrides waste energy because we are often overriding something to make somebody comfortable, putting it into occupied mode, raising the temperature or lowering the temperature. And this tends to waste energy. A prime example of that gets back to our systems that have variable speeds on them, such as our pumping and our air handling systems. And we see that by changing the amount of fluid we're flowing, whether that fluid's air, water, or glycol, we can impact our energy consumption on the motor. And as an example of that, the change in power requirement of a motor relative to the change in how much fluid we're flowing is not a linear relationship. It actually happens to be a exponential relationship where it follows what we call the fan laws. And the fan laws basically state that for a change in speed of the motor, you're going to see a reduction or change in the power requirement of that motor according to the cube of the ratio of the two different speeds. So if you start at 100%, you reduce it down to 50% flow. That's effectively a 50% reduction in the motor speed. By the cube law, in other words, 50 over 100, 0.5 times 0.5 times 0.5, that's only 12, just over 12% of the power requirement of the 100% flow. That's a huge reduction. That's why, that's one of the major reasons we use variable speed drives, is to get that incredible power reduction that follows that cube law. Now, is it exactly 12.5% by following that? Well, there's some other guiding factors that don't make it quite 12%, but there is significant reductions in energy consumption by reducing speed, motor speeds. And so we can get that in our air handlers, and we can get that in our pumps. So it's very important to look for that. Now, one of the manual overrides we did not talk about earlier is an override of a position of a balancing valve on a hot water or chilled water system. Robert's laughing because I harp on this every time, don't I? Quite often, I do this when I'm taking my students through energy audits, and I look for this every time I do an energy audit myself. I look at where the balancing valves are set on every system, and then I go, okay, is it 100% open, or is it something less? If it's 100% open, I'm expecting that I'm expecting that system to have a variable speed drive on it, because the variable speed drive allows it to go from 0 to 100%. Well, not down to 0, but say 20, 30%, up to 100%. If it's less than 100%, then I'm expecting to see a constant flow system, and I'm expecting that valve not to be much more than, say, less than 70% open. If it's 70-80% open or less, then I'm thinking, oh, there's changes to be done in the system to save energy. So when we're looking at this power reduction, we look at that curve, you get a lot of savings by reducing your flow rates. If we can avoid using a valve or a damper to change flow rates and use a motor instead, there's tremendous energy savings. And we always want to do that. So that's with flow rates using VFDs. VFD being a variable frequency drive. Some people call it, if you're on an air handler, VAB, frequency drives, however you want to term it. So other examples, outside air dampers. Any overrides on those, quite often it's going to be, it's too hot in here, let's bring in outside air because we don't have cooling on. Open dampers 100%. So potential for energy waste there. Good indoor air quality, but energy waste. So these things can have competing impacts, right? Which is why we use that CO2 demand ventilation process to provide us with enough outside air to be comfortable in the space, be it save energy. Occupied, unoccupied, very common one. We talked about that beginning of the day with just scheduling of events. And I've seen school districts where they will, if it's a regular event, they'll schedule it into their system on a regular basis. But they'll often use overrides for an emergency event or something that's not regular. And in those cases, forget to take them off, and they end up wasting a lot of energy. And I track energy use for school districts. I've done hundreds and hundreds of schools over the years. And you can see when people tend to do too much overriding, it shows up in energy consumption. And so it's very impactful. You can see it, you're paying for it. So you want to watch for that increase in energy use and the impact it has when you're just putting overrides in place. Resets. And so there's pressure, temperature, dish. I gotta move mine. So you have pressure, temperature resets for discharge air, hot water, chilled water. Then you also have VFD settings, all the different aspects I mentioned, fan modes or fan laws. And just keeping in mind that most motors don't like to be much lower than 20 or 30% load. Otherwise you start acting weird. We have some ECM motors in our lab at school, and those don't like to operate when you get down to 20%. They start to stutter. So you have to have them 25 to 30% in order to function properly. What's been your experience, Robbie?
Very similar numbers. The other caution I would offer with trying to run motors at low speeds for long times is potential overheating issues.
Even with if you buy a new motor that's designed for it?
Yeah, even if you buy a new motor that's designed for it. And yes, we are, for those who had asked for it last week, we will talk more about VFDs. That'll be in 2 weeks on week 4.
This is also a good point to caution again against just putting a VFD onto an old existing system without considering replacement of that motor. So that's the energy impacts of overrides. And as we mentioned with outside air, it can also have air quality impacts. So you want to think about those things when you're looking at it.
And I've got 2 quick ones to add on to that.
Okay.
You may think that overriding something as small as a VAV damper, hot complaint in the room, override the VAV damper, open, no problem, right? Keep in mind that you're dealing with potentially very large and complex systems. If you're opening up that damper further on that VAV box, it's going to affect the next VAV box down. It's not going to get as much flow. So it's going to open its damper further. And so will the next one over and the next one over. And because of this one simple change, now you're moving up in your having to increase the speed on your VFD at the air handler. And, you know, it may only be a few percent, but as we can see from the graph here, a few percent can be really significant in total energy usage. And that 1 point on that air handler that's only 1 point where we're additionally using energy. If we leave that override in place on the VAV box too long, maybe the room gets too cold now and it has to open up its hot water valve. Now we're consuming hot water where we didn't need to before. Or still back up at the air handler with that increased speed, maybe we need to open up our chilled water valve or our hot water valve a little bit further and further complicate the base issue. So the impact of overrides is not a simple one-to-one type situation. It very rarely is, unfortunately. But that also means that it's really hard to predict how much energy is being wasted because of overrides.
There's all that interactive impact.
Yep. That's all I got on that one.
Yeah, just getting back on the savings aspect. Here in my area, I've done some analysis, and you can count on in the heating season that your system's going to probably be at about 67% load on average during the heating system. And at 67% load, if you look at that, reduce your fan speeds according to that, that's going to be a 30% horsepower requirement. So you're going to save 70% of the fan energy just by using a VFD method of keeping the space comfortable. So, all right, that's all I have there. I'll move on to the next slide. And that opens up for questions for anybody.
Anybody have any questions on, well, let's touch on energy savings or impact of overrides, excuse me, first. But if we don't have any questions there on anything else we covered today, there's only one slide after this, but you want to stick around for it, please.
It's not on the overrides, but I was wondering if you have like an energy audit checklist that you used to use when you went through and did your sites, because I've just been drafting all mine from scratch this whole time.
Yeah, and in all the years I've been doing it, that's basically how I've done it, because buildings tend to be so different. ASHRAE has a number of different forms that are available through their energy auditing guidebook and now through their energy auditing standard. Those spreadsheets, for me, are far too detailed.
Yeah, that's what I found. And all the ones I looked at were just way too intricate and not something I could do in a quick site visit and as one person. My intentions were honestly, as energy manager, to educate a lot of my consumers and start to offload these kinds of audits onto the students and create what they call energy champions at my sites, and maybe even get stipends from them. But it's all, you know, it's a 3-tier kind of plan that I've come into this. The first thing I needed to do was baseline, you know, to get an accurate state of affairs. And what I found was that we weren't entering the usage in right at all. So it threw the whole, you know, baseline off. So I don't even know how I can fix what I got when I don't even know what I got.
Yeah.
So that's the main thing I've been working on for months, and it's definitely been a labor of love. But I think I got in a place where we're kind of accurate. And what I've done recently is Delmarva Power now has an energy manager portal where you can literally enter all your accounts and see the usage in real time. There are quirks with it, and it is recently developed, so keep that in mind.
It's progress.
And we will be going through a little bit about that tracking information. This is the last day, I believe, right, Robbie?
Yep. Yes, sir.
Yeah, forgive me if it's off topic. I mean, I'm
No,
ADHD,
it's
and
okay.
I like to send things when they hit my noggin. Otherwise, they just go back out to the
Yeah.
stress.
Yeah. Have you looked at DOE's site for schools, and they used to have a book called Tool for Schools.
Oh, I had a lot of federal contacts that have disappeared as of late and stopped responding to me.
Yeah,
So that's kind of the state of affairs that I threw a lot of hooks out there and I thought I was getting somewhere, but now the emails are bouncing back, and I actually know a federal employee that's looking to become an energy manager and coming to me asking. Well,
yeah, that's unfortunate. Yeah,
Other questions?
I'll take a look at what I have.
yeah, nothing big. I mean, like I know mainly you want to look at the envelope, you want to look at plug loads, and that's what I'm basing it out of. More of looking at the cultural stuff. I started looking at the mechanical rooms in my last round, and I was like, this has to be a whole separate audit. Like I have to look at what the teachers and the students are doing in the school and check, those base level things, and then the mechanical room, because we do have issues with mechanical stuff that I'm not always abreast of either. So I really have to do my research before I go into the.
And just remember that getting the students involved, the really important part about that is they have a huge impact on the behavior issues. And how people use energy. And so that is of great value. Great value.
And also we're planting the seed for the future. If we start them off doing good habits, reducing energy, stuff like that, maybe we can reduce the stress on our grid, because we know it's already hurting.
Yeah.
And there's no way that they can instantly just start throwing up new power plants to meet the demand that we're facing.
Here in Wisconsin, there's a program that called KEEP, which is for bringing instructors or teachers from schools in, and they teach them about energy and type of things you mentioned with energy audits and how buildings use energy, so that they can bring it into their classrooms. And so I'll see if I can't find a contact for that and have you can then reach out to them.
So the first step we're actually doing is a energy poster contest. And that's like the introduction to this. And then I'm going to do a presentation, all the principles showing the site usage and all that. And that'll be the segue. And then my next contest will be, awards for who can reduce their EUI year over year at their site. And I'm going to reward everyone that gets a 2% or higher reduction. Maybe it'll be a barbecue for everyone. I don't know. I got to find the money, and I got to put the plan together.
So just remember, you wanted to find that 2% relatively tight if there's money involved, because looking at the whole building energy consumption and comparing before and after for savings, you'd be lucky if you can see much of a change if it's not less than 5, maybe 10% of a building reduction. So, and I don't know if you're going to have that huge of an impact or not. So you might just keep that in mind. But if you're just doing it just to encourage, then who cares?
Yeah, if I get any reduction, I win.
Yeah.
If I spend $500 awarding the schools and we save, $10,000 in energy, that's a win.
Yeah. Or if it helps the teaching aspect for future generations, that's a win.
And make them conscious, turn the lights off when you're not in the room, or even basic things. Or I don't think a lot of them even know how much energy the items consume. And that's why I've set up kilowatt meters, and I've hooked up laptop chargers, monitors, see what they do idle. One of the worst things I'm finding, though, are laser printers.
Yep. They consume a lot.
Way more than you would think. The industrial laser printers are crazy.
Yeah. And the old ones are terrible.
Any other questions on stuff that we covered today? So Antonio says, from our experience, being laser focused on what happens in the off hours is what yields the most waste reduction.
Yep.
That's a great place to put your attention.
Walking those buildings at night is important.
Yep. All right. So that's it for today. We do have homework again for next week. We will be focusing on alarms and schedules, and we will be getting into our virtual environment. We'll be getting into the BOP test system, and we're going to do that some right at the beginning so that you can start getting used to it and kind of play around while we're going through some of this. Okay. Also, a reminder from Larry, if there's anybody who has not already done so, please enter your full name into the chat, just for our attendance purposes. But your homework for next week is going to be to find an occupancy schedule for one of your buildings or one of the areas in your building, and determine, does it closely match the actual usage of your building? Sometimes it will, sometimes it won't. If it doesn't, obviously you've got some opportunity there. The other item I'd like you to do is to find in your BAS an example of a useful, please note that word, alarm. Okay? Record as many details about that alarm as possible that makes it useful to you. Okay? I don't want to know why it's useful to Carl or useless to Carl. I want to know what makes it useful for you. Because alarms can be an amazing tool, or they can be a horrible waste of your time. Be ready to discuss them next week. If you don't have any further questions, that's all we got this week. You will get 2 breaks next week, by the way, since we'll be going the full time.
Thank you, everybody.
Thanks. Take care. We'll see you next week.